This is going to be painful again.
Oh, most certainly, but I mean, that's kind of why we're here.
Yeah, suffer for punishments.
Alrighty. We are live. No viewers yet, but I'm sure that will eventually come in time.
Oh wow, you just put it on 30 seconds ago, and you've got the horny devil going.
Oh, you saw the thumbnail?
Yeah. Well, I've got to bring up the chat, so that way I can pay attention to what's going on as well.
Fair.
And it gives you at least one viewer for it.
Thanks. But yeah, last minute I managed to create the demon Lystrosaurus for the thumbnail.
Yeah, at least you didn't follow my idea of it, but my idea was a bit weird. The demon Lystrosaur lording over Scrat as he's trying to cleave the Holy Bible onto everyone.
Maybe that'll be episode 3.
But it more fits in with the Ice Age.
Just make the demon Lystrosaurus our mascot or something. Have him show up in every thumbnail doing something nefarious.
Well, the closest things to real demons that you can really think of when you actually describe how they were able to thrive during that hellscape.
True. Oh, speaking of hellscape, he's saying something about the geological equilibrium.
That's like saying genetic entropy.
Yeah. Actually, sorry, really quick, I gotta do a thing. Let us begin.
Equilibrium at the moment, even though we still have movements of faults and volcanoes going up, but it looks like a lot less than immediately after the flood.
So he claims.
Now, we know that volcanoes cause cooling, in fact, global cooling for the larger volcanoes, because in historical time...
Well, volcanoes do cause global cooling, don't they?
Indirectly. They actually cause immediate heating. For some
but I'm talking long term.
Reason. Yes, and it's actually the side effect of all the stuff they eject in the air and the sulfur. But on the short term, they actually create a massive influx of heating.
True.
And if there's something like a flood basalt eruption, that causes only heating.
So actually, that does make me curious. I wonder if any of the Yellowstone eruptions had an effect on the ice age that was happening at the time.
When it comes to when you're talking about the VEI, anything lower than a 4 only does heating because it doesn't actually propel ejector up high enough to blot out the sun. If you start getting into the really big ones, that's the only ones that actually create enough. Like Krakatoa was able to affect the global temperature by about 1 or 2 degrees. So they did have a year without winter. Mm-hmm. But Hawaii is a volcano system that is constantly erupting, and it actually is increasing the local temperature because it doesn't. Its ejector barely gets a kilometer into the air.
True. But like most of the Yellowstone eruptions are recorded as like an 8 or a 9, aren't they?
No, a 7 or an 8.
Well, even so, that's still pretty big.
They do affect global climates, but like I said, anything lower than a 5, it only is a local effect. It's when you actually start getting into very large stratovolcanoes or supervolcanoes, that's the only ones that actually really affect global temperatures.
Right.
So if it's a supervolcano, it could lead to an ice age. If it's a large stratovolcano or a smaller stratovolcano, it could actually just heat up the temperature in the other way.
Interesting.
Well,
Times
like I,
we've measured.
said, I should just remember at the top of my head the name of that bloody Chinese volcano on the border of China and Korea. That one actually increased the global temperature 4 degrees.
4 degrees.
Yeah, only for about 3 months.
Well, even so, that's pretty big.
Because when it was forming, it was actually a flood basalt eruption because of the way that it was, because it creates a higher viscous level of magma when it reaches the surface. Therefore, the lava flows a lot more freely. That's why, if you look at the geological features in that area, it's a large igneous province, not just a stratovolcano.
Okay. Oh, also, side note, I actually have something to drink this time because I wanted to try something.
Oh no!
It's nothing-
I hope your girlfriend can carry you to bed when this is finished.
Hey, I'm not doing like a drink per dumb thing he says. If he did, I would be in a coma.
Yeah,
I'm
I
just
think it'll be
sipping on
further than
something.
that. Yeah.
It's a half amaretto, half root beer. It's actually really tasty.
Interesting.
Mhm.
If only I could drink, I could try something like that.
As long as you sip it, it tastes a lot like a vanilla cherry Coke.
I don't like vanilla cherry Coke.
Well, then you might not like it.
Hey, don't knock something until you try it.
Agreed. Though I'm not sure we should try young Earth creationism.
No, we've
Measured
tried
this.
it, but
For
we've
instance,
rejected
when Mount
it.
Tambora went off in 1815, that's the largest eruption in historical time. It caused volcanic ash and aerosols to go around the globe, and it caused the year without a summer, they call it, in 1816 in the Northeast United States and also Northern Europe. There was crop failures, summer frosts, harvests that failed. We know that volcanoes cause cooling.
Fun fact, and I would have to double check this, but I believe the dreary weather caused by that eruption helped inspire Mary Shelley to write Frankenstein.
Yes, it also caused the Irish potato famine.
I thought the Irish potato famine was caused by the British buying all their fucking potatoes.
No, it's a combination of multiple things. They
True.
had stopped doing multiple species of potato.
Because they were doing cash crops.
Yeah, and the English were buying it in large quantities. It basically was a cavalcade of fuck-ups.
Yeah.
And multiple points of failure just collapsed it. That's the entire thing behind it, but that's just a different matter.
Other volcanoes cause cooling, like Krakatoa caused cooling, Mount Pinatubo, El Chichon. These were volcanoes that went. These last two are volcanoes that went off in the last 30 years, and these have all caused a little bit of global cooling. Generally, about maybe 0.8 of a degree Fahrenheit for up to about 3 years. But these are small volcanoes compared to those immediately after the flood. We have evidence that some were so huge they block out most of the sunlight for a month or two, and these strata.
Which ones?
There was one in Peru that he was talking about, El Choa. It's one of the more constant. Yeah, that one's constantly going off. It's quite a large stratovolcano, but it has no effect on global temperature. It's more of a local thing because it barely gets up to very high on the VEI. And
I'm curious if he's gonna try to tie this into denying climate change. I'm very curious if he might try that.
Oh God, no! Please don't say he's that dumb. Oh yeah, he is a climatologist.
I was gonna say he said a lot of dumb shit.
Yeah, I just realized who I'm talking about, but then it comes down to the last two he claimed barely affected the global temperature, like about 1/10 of a degree at most. I've gone through and explained it on the last episode. If you add up all the sizable eruptions, just using that one sample of igneatite, you'll end up with something like a VEI of 16. That's talking about half the planet erupting off.
Yep, just global death.
No, this isn't talking about global death. This is talking about half the half of the planet is the caldera.
Right. Sorry.
Yeah, that's not global death. That's planetary annihilation.
Maybe we'll still have some tardigrades in the upper atmosphere or something.
Possibly, they might end up in the next solar system. There'll be enough.
Stratovolcanoes.
There'll be enough
That's
energy to do so.
Terrifying.
And why is
that
he only
went off
exclusively
at the end
going
of the
on
flood, and mainly
one type of volcano?
I mean, stratovolcanoes are
The most
big
common,
and
and
explosive. That's probably why.
yeah, they're not the most common though. They're the most definable because of their behavior. So why doesn't he talk about the other ones?
Let's see. If I'm remembering my volcanology right, you have shield volcanoes, cinder
Which are the most-
cones, and essentially a combination of the two is
Yeah.
stratovolcanoes, where sometimes it'll do floods, sometimes it'll do big explosions.
Which is where the super volcanoes come into it. Because they're
Right.
kind of a combination of the both, simply just the sheer magnitude they are. They don't have the sides that you would expect on a stratovolcano, but they go pop goes the weasel like a stratovolcano.
Pew!
Round and round the planetary bush. I don't
Early
want to sing the rest of
post-flood
it. All I can think
were
is dirty
huge.
words.
Look at the size of these cones. These represent tremendous volcanism and sending up huge layers of ash and aerosols in the stratosphere. And these are just in the Cascades here, maybe a dozen of them. Is just a few of the hundreds across the Earth that were going off early in the Ice Age to replenish that ash and aerosol layer left over from the flood. And all this post-flood volcanism reinforces the ash and aerosols in the stratosphere to continue the cooling for hundreds of years.
No, that's not how volcanoes are formed.
He's just pulling all this out of his butt. That's all.
Volcanic formation is nothing like that. Stratovolcanoes start and they gradually build themselves up with minor constant eruptions. So it just builds up and builds up and builds up. And
Until
then,
eventually they cap themselves and then boom.
then they go pop goes the weasel. They don't just go boom and look, stratovolcano. No. A lot of those stratovolcanoes are extinct because they're no longer near a magma chamber, and the magma chamber has moved.
Mm-hmm.
That's why there's lots of them, not because they all went boom at the same time.
Yes. Side note: we should be kind of grateful that there aren't any subduction zones in the Atlantic, or else I feel like a lot of civilizations would have just been gone. There aren't any, are there?
There are. Where do you think Pompeii came from? Oh, sorry, I nearly did the wrong thing and called Vesuvius Pompeii.
Well, Vesuvius is it from the African plate going into the European or Eurasian plate?
It's a combination of one of the expanding Atlantic plates going under the Is it under or over the African plate? It's a similar thing to
It'd
the way
be under, right? Because
you've got the European plate, then you've got the African plate going underneath that, and the Atlantic plate going underneath that. But I forgot if it's going underneath the African plate or over the African plate. I'll have to look at the seismology again, or just look it up. It's not that important. They're all down there.
Okay. Yeah, I guess I forgot about Vesuvius. Is that the only volcano in Europe?
No, there are about a dozen in Europe. It's just the Vesuvius is the most famous because of what it did.
Huh. Yeah, what do you know? There's like 7 or so in Italy alone.
Yeah.
Sicily has 2. Huh.
Okay, there's about 2 dozen.
Okay.
There's one in Spain went off 2 years ago.
I don't know if I heard of that.
The one in Norway went off in 1985. The Iceland one, which always goes off anyway, so
Apparently, there's supposed to be one in France and Belgium.
Yep. They're all
Huh.
over the place. It's just the fact that they're not as active as the Ring of Fire for some reason. Well, I can give you the reason, but that requires a long explanation. What do you want? Fur Demon. She was sitting on the back of the chair. Now she wants love and attention.
That's fair. I don't know where mine is. Probably off sunning himself somewhere. All right. Let us continue.
But you see what I mean? That you make a comment that, oh, there's no volcanoes that I'm aware of in Europe. There's about 2 dozen of them. So,
I mean, hey, we cover each other's weaknesses.
Yeah. But volcanology was something
experience.
that I was volcanology was something that I was really, really interested in getting into, but both in my condition and my marks, I didn't actually get into the volcanology courses. So I got stuck with stratigraphy.
I always found it interesting, but I went into college knowing what I wanted to do.
I was just interested in geology. I didn't actually do it with an end goal. I just did it because I like the stuff.
Yeah, and that's totally fair.
Because I'm too injured to really actually do anything with it. It was more of my own personal curiosity that drove me.
Right. Well, let's see what Michael isn't curious about. Or whether you just next thing he claims.
The second mechanism for an ice age is abundant moisture. Where does that come from? Well, after the end of the flood, the oceans were very warm. Why? Because the Genesis flood was a tectonic volcanic event, and a lot of probably groundwater was added to the pre-flood ocean, so you'd end up with a warm ocean from top to bottom and from pole to pole with no sea ice. Well, the significance of this is that with a warmer ocean, you get much more evaporation into the air. For instance, at an ocean temperature of 86 degrees Fahrenheit, you get 7 times the evaporation as you do at water that's 32 degrees Fahrenheit. So with warm oceans at mid and high latitude, you get tremendous evaporation. And this moisture would get caught up into storms, and the storms would have so much more snowfall that would turn to ice for a rapid ice age.
That's not how that works. Warm storms are normally referred to as what? It begins with a T. I really cannot think of what that word would be. Tropical?
Tropical typhoon?
Tropical storms.
Yeah, I know. I'm trying to joke.
Yeah, but tropical doesn't mean snow, does it?
Not usually, no. But he is right that warmer water will evaporate more because, duh, that does happen.
Because it's already got enough energy into it that it needs a lot less energy for it to actually convert from liquid to gas. That's a given.
Yeah, but he just says, oh, there was the flood, so we had a ton of storms, and that led to a ton of snowstorms, and that led to a ton of ice and ice age.
And then anyone who understands it just goes, it doesn't work like that.
Yeah. I mean, granted, I do remember that there is a phenomenon where you'll get a ton of evaporation from the equator, and it'll travel right up to the poles, basically.
But that won't work if everything is very, very warm. It would require the poles to be very, very cold, creating more of a greater circulation effect from the poles to the equator.
And actually, that I know that's why a lot of our major deserts are all at about the same latitudes. because the water vapor is just coasting right over them. It hasn't really cooled down enough to condense and fall.
That's not entirely true. It actually has more to do with the landmass.
Isn't it a combination of both?
It takes a little bit more combination of both than just one or the other. There's not just one particular reason.
I suppose. Gee, you're saying things in life aren't just black and white?
Sometimes they are. It's just more the fact being that when you're talking about very complex systems, the answer is very complex.
Yeah.
Like if you go to sub-Sahara Africa, of course it's going to be very, very dry because it's got to go through most of Africa before it gets there, and most of the rainfall has already been taken out. Then you've got things like the Central Australian deserts. If you look along the coast, lots of rainfall, but when you get to the middle, dry.
Right.
But then you got the deserts in the Andes Mountains. It's more to do with their altitude than anything else. And that's why they have the Amazon basin, because of the Andes Mountains.
Right. And I mostly have to go off of what I remember from Geo 100, you, and Google, because I'm not a meteorologist. But at least according to Google, it says just the proximity to the equator means that even if stuff does rain in those areas, it'll evaporate really, really quickly. So
yes,
it just gets dry all over again. And that's part of what keeps it dry.
That explains things like the African deserts. But like I said, you've got other ones like northern Mongolia is a desert, but for a slightly different reason. And
same for the American Southwest, right?
That's a
mostly
similar
because of
reason.
the Rockies.
Yes.
Alrighty. Well, let's see what the next thing he gets wrong is. Or did you have anything else to add on that?
No, it was just a slight addendum to what was being said.
Dr. Larry Vardaman has modeled the effects of a warm ocean in various storm patterns in the Eastern Pacific. He's warmed up the temperatures, and he's shown how much precipitation you get in the Sierra Nevadas as well as Yellowstone National Park. And what he discovered is you get something like 4 to 8 to 4 to 10 times as much precipitation with a warm ocean off the coast for the Sierras, which had an ice cap, and also for Yellowstone Park that had an ice cap 3,000 feet deep. Another effect of the warm oceans, besides heavier precipitation, is that they would cause milder winters in the northern hemisphere as well as the southern hemisphere.
I honestly don't know if that's true.
Well, to poke a hole in one of his claims, the 4 to 10 times the amount of rain on the Yellowstone area, the only thing that he actually heated in his experiment was along the equatorial region. But
the global ocean?
No, he didn't do the global ocean. He did the global ocean along the equatorial region. And yes, it was a lot more precipitation as rain, not snow.
And I'm trying to see if I can find a chart like the one they showed where just, evaporation scaling to temperature.
It has, it shouldn't be a lovely logarithmic curve like they showed. It actually is a lot more. It shows it's more like dealing with electrons when the way that their energy. You actually have 3 particular jumps of it.
At least according to what I'm seeing from Google, it is a curve. It's just not a logarithmic curve.
Yeah. But there should actually be 3 particular jumps in it as well. But that That's
So-
just a better understanding of what's happening with it. See the evaporation rate?
Why
See
would
how
there
that-
be 3 jumps?
Because of the way the electrons work when it's shifting from one state to another.
Like here, the graph seems to bump
Bend.
up twice.
Yeah, see how it's got two bends in it.
Yeah. Okay.
Because you're not just changing, you're changing state and changing energy within the system. And because of the way electrons work, they build up and build up and build up, and then they have a little bit of leeway. So that's where it just levels off for a little bit, and then it goes again. So it should just jump. Looks like a sort of 3 jumps to it.
Huh. And I wonder how this would be affected if you have like continued evaporation without any precipitation. Like, so the concentration of like oxygen 18 or H2 gets higher.
Again, you've only got 3 states where the electrons can go, so you'd only see the 2 kinks within the graph.
Okay.
Well, what that we're aware of, I don't think anyone's ever seen a 4th state within the electron, so within the system. But there actually might be, so that would be actually interesting.
I mean, I guess maybe it's just pump enough energy into it, right?
That's why now my brain is starting to think about the LHC and having a look at some of the results from that. But that's got nothing to do with geology, so...
Hey, maybe we can have an after show if we finish it tonight. Or today, for you.
The way that this works is warm oceans heat up the air that spread inland, especially in wintertime in storms. And with the Arctic sea ice gone, it all adds up to much warmer winters. They would be below freezing in many areas, but they would be warmer than today. When the evaporation that comes from the ocean condenses, you add all that what's called latent heat to the atmosphere, which also heats up the atmosphere. So the climate in the early ice age, right after the flood, is one of cool summers and mild winters. So
Okay, so that little bit is right, correct? Like the formation of ice requires a release of heat.
But the problem with the system that he's talking about is you've already got a warm ocean, and the warm ocean is usually linked to because the air temperature is higher.
True.
So with the higher air temperatures, there would be no way for ice and snow to actually form and stay as ice and snow. And
True.
water vapor is also a greenhouse gas.
It's pretty potent, isn't it?
About the same as CO2.
Okay. Yeah, but I just remember from glaciology, at least, part of the reason why you have so much liquid water in glaciers is because whenever it freezes, it releases heat to all the water surrounding it, helping to keep that water liquid, even as that first bit of water freezes.
And there's also one other thing about it that you keep forgetting about.
Friction?
No, pressure.
True.
What does pressure do to ice?
Well, it can drive it towards being water, right?
It lowers the melting point. Water
Right,
under...
right. I used wrong words, right idea, right?
Yeah, right idea, but it's better to describe what's really happening. It's
True.
if you've learned anything about the way propellers work, especially within submarines, the reason why submarines have so many blades on their propeller is because they cause cavitation effects. Because the deeper you go, the lower temperature that is needed to actually create boiling water. As a propeller goes through the water, it creates friction, and at a deep enough depth, what you're actually doing is boiling the water off, creating air bubbles which pop and create noise.
Mm-hmm.
It's a similar principle. If you compact ice enough, the melting point of the temperature might even end up to 20 degrees below zero.
True.
Yeah, so the more pressure you put under a system of water, the lower the melting point.
Right.
That's why it ends up full of water.
And then I do know that there is another thing with glaciers too. Just due to how the water interacts with most rocks, there's almost always a thin, like super thin film of water in between most rocks and ice. And that helps them slip under the bed, and it can also make it easier for more water to appear.
Yeah, most rocks are not porous.
Yep.
You'll mostly see a different sort of interaction when you get to sandstones, which
Well,
are porous.
And even if they are porous, they can only hold so much.
Yeah. We don't want to go into the T-Rock dude's discussion with his bloody aquifers.
Actually, sorry, that does bring up something that kind of bugs me in debates, where people bring up hydrothermal vents. Now, correct me if I'm wrong, but essentially what feeds them is water seeping into the muck and rock beneath, and then it goes down, gets heated up, and then feeds up through one of those, right?
Yes.
That's where
It's
most of the
normally
water
be-
comes from, not from an aquifer.
Most of it comes because they're within an artesian basin.
Oh, okay.
Well, a lot of ejecta is porous, but basalt
True.
is not. So when you have a line of basalt and then you have something like ignitite sitting on top of it, and it's in a caldera, you've created a natural aquifer. You've actually created your own artesian basin. So rain will fall in, it will collect in underground, and that's what will power the system.
True.
It's
Though I
not
will
that
say
difficult.
some basalts can be rather porous. It depends on the basalt.
Yeah, some, but the majority are not.
Fair. Like I'm just thinking of in particular, a few years back, my hometown, they got new rocks over the railroad tracks, and for some reason they decided to use basalt. I have no idea where they carted it in from, but it was extremely porous material.
Oh, it might have been popcorn basalt. I can't remember the real name. It's called popcorn basalt because it's all fluffy and.
Yeah. I don't remember the real name either, but
You know what I'm talking about, and you can picture it in your head.
I know what you're talking about.
But you understand why it's called popcorn basalt, and it's not the best material for anything, really.
Yeah, they just use it as filler around the railroad ties.
It's very, very porous. But that usually forms on a very small eruption events, and that's normally where it comes from.
Here we go. Is it vesicular basalt?
That's it.
Yeah, vesicles. Right. Okay, for some reason the first search showed an image of a furry, but this one isn't.
Yeah, but you can see why it's called popcorn basalt.
Yeah.
Yeah, don't ask me why. That's the only thing I can remember of it.
I mean, it works.
It describes it perfectly. It's just as soon as you start describing it, you go, I know what you're talking about.
All right. Well, let's see what Mikey has next.
So you had very little seasonal contrast at the start of the Ice Age. Another effect of the warm ocean is that it would keep some areas that were glaciated unglaciated until the middle or the end of the Ice Age. For instance, where you had onshore flow of warm air warmed by the ocean water, the glaciation would delay for a number of years. For instance, along the west coast of the United States, like the Puget Sound area, probably didn't glaciate till midway during the Ice Age. Same thing in the British Isles, which probably didn't glaciate till midway in the Ice Age. Also,
I feel like that onshore flow could be true, just because it would promote more melting, but I could be wrong on that.
Not to the extent that he's trying to put across.
Right. Especially since he's trying to condense it all into one ice age.
And as well as he's talking about a warm ocean which wouldn't have very strong currents. So what he's just showing now wouldn't quite work because that would melt the majority of it, and because you would create, if the oceans were warm and the land mass was cool, you would have massive air currents just flowing in constantly.
Right.
It just creates he's doing it all in the wrong order. Yeah. Ice ages usually occur when the temperature is lowering enough worldwide. If you have a hot ocean and a cold land, it would create massive thermodynamics kicks in. So it would never be able to ice up properly. You might end up with what we've got now of the high peaks with glaciers and the lowlands glacier free. For it to actually be glaciated to the extent of what you would see in the ice ages, especially the last one, you cannot have a warm ocean.
Yep. Or at least the majority of it can't be warm.
You'd still have equatorial regions which are warm, but that would create... it's... Your northern and southern hemispheres could not be warm oceans of what he's trying to present. You couldn't have the entire ocean warm.
Mm-hmm. Oh, also, hello, John and Hill Hugger. Welcome back.
Welcome back for the migraines.
Hey, well, at least I'm not quite there yet. We've only gone through 4 minutes.
This onshore flow of warm, moist air would affect the Arctic region, because with no Arctic sea ice and the Arctic Ocean probably starting at a temperature about 86 degrees Fahrenheit, you could probably swim in the Arctic Ocean for a while after the flood. This warm water would warm the air and add moisture and cause the lowlands of Siberia, Alaska, and the Yukon to be unglaciated. Not glaciated, it's only the mountains of Alaska, Siberia, and the Yukon Territory that were glaciated, which is a major mystery.
Okay, sorry, I wasn't the only one hearing a growing ringing there, was I?
I just heard the ringing as well. I think it was more to do with the movie itself, not us.
Yeah, I was like, holy shit, is that a migraine?
It sounded like it, but no, I think it's what he's done. And how is he saying that the Arctic was uniced that caused the Ice Age?
Well,
No!
He's saying that during the global flood. Not during the Ice Age, I think.
But during the Ice Age, the Arctic was most definitely iced up.
Oh, I agree. I think he was just saying it wasn't during the flood, and then it became iced over.
But it was iced over before the actual Ice Age would have started, so again...
No, it wasn't. The world was covered in flood, and the water was warm. Haven't you been listening?
I am going to throw our mascot at you if you keep that up.
Of Earth science. When they run their computer models of glaciation, often some of the first places to glaciate are the lowlands as well as the highlands of Siberia, Alaska, and the Yukon Territory. So they're perplexed on why these areas were not glaciated, but yet we can explain it with the post-flood Ice Age model by warm onshore flow of moist air in the Arctic. This also...
But they were glaciated, though. You're just an idiot who's trying to promote his propaganda.
Yes, he's talking about when there was a period in which we didn't have the Arctic ice, and this is what they're giving examples of what climate change will do if the Arctic ice sheets melt completely, as well as he's giving models of climate change. They're not they've got nothing to do with glaciation effects.
Mm-hmm.
But
I
as
am
for hill
curious now,
huggers,
though.
when you talk about basalt soils, that's usually made up of, as we referred to before, the popcorn basalt, because of
Yep.
the way that it's actually ejected. Popcorn basalt is usually created from clumps of lava that is ejected out of a volcano, like you get around Hawaii. There are two types of basalts that are very distinctive when you get to Hawaii. You've got the flow basalts that you'll see on the flow plains, very hard, very tough stuff. And then if you get up around where it's ejecting, you'll find lots and lots of rocks made up of the popcorn basalt, which breaks down
Yep.
incredibly easy into your basalt soils.
Mm-hmm. And let's see, when they fly out, there are different size categories, right? Is the biggest a bomb, or does it have a different name?
Uh, yeah, they actually have names like bombs, and they get quite sizable as well.
Mm-hmm.
You can get them up to 200 or 300 meters across in some of the ejector events. But if
Sorry,
you watch
two
one
or
of the
300. Did you say
meters,
200 or 300 meters?
yeah, you'll find
What the
some
hell
from
through that?
Yellowstone.
Okay, that I can believe.
You'll find them around Toba, Topher, Yellowstone. You'll find boulders of this stuff. I mean, 100, 200 meters of this stuff.
Jeez. Like, like logically, I understand they could throw something that big, but like my human mind just does not want to compute something that big flying through the air.
It's literally a melted blob of rock flying through the air, cooling, and yeah, it's the idea of it terrifies you. Like Krakatoa's, the largest around there was about 20, 30 meters. But around, like I said, around Topher, Toba, and the Yellowstone, you'll find them 200 meters. These are huge.
Something that size, I almost wonder if like only the outside shell would have cooled and then just like burst open when they hit the ground.
That means it would have been even bigger.
This is just getting worse.
I
Also,
wasn't
would
going to
cause
mention
heavy
that.
precipitation.
Like volcanoes are cool. They're also insanely terrifying.
We're not even getting into pyroclastic flows yet, and that's the most terrifying aspect of it.
Like no joke. Oh yeah, those are horrific. Whenever there's a movie that involves a volcanic eruption, it always sets me on edge because I've seen what those things can do.
Yeah, volcanoes are awe-inspiring, fascinating, but if you're not terrified by them, then you don't understand them very well.
And just the scariest thing for me is if you're not far enough away, there's nothing you can do. All you can do is just sit there and watch your doom flying at you at over 100 miles an hour.
How do you think the guy that was taking photographs from his van felt?
On Mount St. Helens.
Yeah.
Oh, just didn't his camera only survive because he protected it with his body? Or am I
He
thinking of a
buried
different
it.
story?
He buried it, and he laid down on top of it.
Right.
It's the only way that the footage that he took survived. Because he knew what was going to happen.
That is beyond horrifying to me. Like, ugh. Ugh. But also, just a really quick distraction. John Rapp, what you said there about the flood, yeah, that's about where we're at. everything's dead and the planet is a barren husk. If what he's saying was anywhere near true.
Yeah, we've gone through some of the things of how stupid he's been saying, and it's, oh, look, all this volcanic energy happened right after the flood. No! Just,
like,
no!
What, like, I know a creationist could turn this statement on me, but when your explanation for how we're here is a series of apocalypses, you might want to question your explanation a bit. Yeah, I know they could turn it against me, but still.
But our explanations aren't a theory of apocalypses. They are extinction events, which are not really apocalyptic. They were nightmarish, but they weren't apocalyptic.
I do agree. Well, maybe not the Great Dying, but I do agree. But I'm saying they could say that because we incorporate extinctions into our model, including mass extinctions.
That's because extinctions will always happen. That's something that is inevitable.
And I agree. But like you know how some creationists will say like evolution is a religion of death. We rely on death to create life. Like that's about the level of absolutely screwed up that I'm thinking right now. Is what they would be saying.
The thing is, this guy actually has a university degree, Hillhugger, whereas a T-Rock is just an engineer. If that, I don't think he really has the same qualifications that I have as an engineer. But that's what you'll find. A lot of creationists, you have a basic background in engineering.
Yeah. Yeah, for some reason, engineers start to see design in a lot of things. What was the like experiment? Was it whatever it was, like the number of biologists with a very specific name outnumbered the number of creationist scientists? Was it the Mike?
Yeah, I think it was Mike, the
Operation Mike or something like that.
Yeah, it wasn't really an experiment. It was they took scientists that actually have an evolutionary background with one name, then they called it operation of that name. I can't remember what it was. I think it was Mike. And it was just these people are all of just one name and they disagree with your stupidity.
Yeah, then all of the creationists by an order of magnitude or more.
Like if we could probably do an Operation Michael and there'd only be him.
I can't find it. That makes me sad. Like that is an amazing story.
Precipitation. So I would predict that early in the Ice Age, they probably were forests that grew clear to the Arctic Ocean. And then as it dried off towards the Middle Ice Age period, these forests mostly died off.
So hypothetically, if there were true, we should find a lot of trees and glacial sediments up that far north, right?
Yeah.
I wonder what we don't find in glacial sediments that far north.
I don't know. But I like the fact that he showed 3 different types of eruptions.
Yeah? Is this Hawaii or? I feel like it might be Hawaii.
Yeah, that looks like Hawaii because you've got a flow on the right-hand side that's older than the one you can actually see that's happening.
Yeah.
The third ingredient for an ice age, it has to persist year after year. And indeed, these mechanisms would persist year after year with the replenishment of the volcanic ash and aerosols from post-flood volcanism to evaporation of the oceans. This would continue for quite a while. But as the oceans cooled, your evaporation would become less and less. And so with time, you would get less moisture, and therefore there'd come a time the ice would build up to a maximum. I estimated that the oceans would probably be about 86 degrees Fahrenheit on the average after the flood. There'd be cool spots and there'd be warm spots, of course, but an average of 86 degrees Fahrenheit. The average temperature of the ocean right now is 4 degrees centigrade or 38 degrees Fahrenheit. So that's a considerable cooling. But because of that cooling, you can time how long the ice age lasted by estimating the cooling of the ocean and the warming factors and adding them up, and you get a change in temperature, change in time.
So my question is, if the water was that hot, how much marine life would be able to survive? Because I know, like, especially invertebrates can be very sensitive to temperature.
Same with corals.
Yeah, corals.
And John was right. It was actually Operation Stephen.
Steven. Okay.
Sorry, Project Steve.
Project Steve.
Yeah, I found it was Project Steve. Project Steve is a tongue-in-cheek parody created by the United States National Center for Science Education, intended to place the scientific debate over evolution into proportion. It is in response to various lists put out by the likes of Discovery Institute of scientists, who supposedly reject evolution, usually lists numbers anywhere between a dozen and 100. Creationists love to claim that famous scientists like Isaac Newton didn't believe in evolution, and more importantly, he was a Christian, of course. No, he wasn't. It's incorrect to say that Newton didn't believe in evolution. He probably had no knowledge about it, which is the truth, as he died 82 years before Charles Darwin was even born. Project Steve, on the other hand, is an attempt to show that these creation scientists are outnumbered by pro-evolutionary Stephen, scientist named Stephen, and alive.
Yeah. Like, when they bring up, like, famous people in history that didn't believe in evolution, like, I am very curious. I'm just very curious, if those people had been presented with the evidence we have now, do you think they would believe in evolution? I feel like a lot of them would.
Newton didn't believe in evolution. He also believed in alchemy. Shut up.
Was it Newton or Kelvin who estimated the world could only be a few 100,000 years old due to
Kelvin.
global cooling?
Kelvin.
But then radioactive decay was discovered, and he acknowledged it could be way older.
Yes. Because he didn't have an understanding of radioactive decay, and that's why he went,
Yep.
oh, it could be where it's a couple of million years old at least. Oh, here's radioactive decay. Okay, it's a lot older than I thought.
Yeah, okay. I can't tell you how old it would be.
That's pretty much how it went with Kelvin, and he admitted it publicly. Yeah. But if you had given Newton all the information we have now, he would have been, yes, it's correct. That's because he was used the same logic of how he actually presented gravity in his presentation on light. But he would still be an alchemist because he's still a bit of a loopy polytheist because he's not an actual Christian.
Yep. Oh, and also just on stream now, the number of Steves within Project Steve, over 1,400 at least.
As of November 28, 2002, the Stevometer numbers at 1,487 scientists on the list.
Looks like it would have. That looks a bit lower than what they're saying here, but
this is under signatories as of November the 28th, 2002, and they call it the Stevometer, based on the list of Steves from the NCSE. But the NCSE notes that Steves are only about 1% of scientists.
Yeah, there sure is a lot of dissent on if evolution happens.
It's basically any scientist within the earth science. It's a percent of a percent of a percent. And most of those are employed by Creation Ministries or AIG. Imagine that.
And I don't know how much, but they probably get paid pretty good for that.
Yes, I'll explain it off stream because I don't want to.
No, I remember.
Yeah, I don't like throwing mud. Yeah, I don't like throwing mud on people in public, so I'll just leave that alone.
Suffice to say, people, they get paid a lot.
And if the temperature changed from about 86 degrees Fahrenheit and the ice age reached a maximum about, say, 50 degrees Fahrenheit, a cooling of 36 degrees Fahrenheit, then I just solved for time, and that's where I got an approximate time of 500 years. It's a rough estimate, and I used maximum and minimum variables for all the heating and cooling factors for the ocean, and I bracketed the time between about 1,700 years and about 200 years. And the best estimate is about 500 years to reach glacial maximum.
I'm just going to take a wild guess and say his math is not right at all. But
No, I think he skipped a few steps because for the oceans to cool down enough to allow for it to not affect air temperature as much, it would also have to drop about 20 degrees Celsius. Where did that temperature go? That's probably what his maths consists of. It's sort of, okay, I need this to drop 20 degrees. Where can it go? I don't know, so I'll just skip that step.
I mean, how much heat do we lose to space?
Varies per year. Also, if you're talking about, we actually are gaining heat, not losing heat.
Yeah. I was just curious how much we lose.
You can't just consider how much we're losing. It should actually be the mean variance in the temperature should be what you're looking at, rather than how much do we actually lose? Quite a fair bit, actually.
Yeah, sorry, like maybe just explanation. I know that. I am just curious how much we lose.
Yeah, but
like,
again,
that's all. I'm not trying to lead it anywhere. I'm just curious about that.
In this sort of context, when you're actually trying to use information, you wouldn't want to talk about, what is just the heat loss, okay?
Mm-hmm.
If you could, because if you're doing that, you're not doing justice to what you need to look at in the overall aspect of it. You need to actually look at the temperature variance over time, rather than how much heat has been gained and how much heat has been lost. That's just part of the equation. This is a matter of we need to talk about the entire equation to correct what they're talking about. But you can look that sort of stuff up in your own personal interest. This is not something that should be brought up in this sort of when we're trying to correct someone else's stupidity, rather than the aspect of curiosity is a good thing to think about, though. But if I remember correctly, it's an order of a couple of thousand degrees a year. But no, the Hillager, within the entire system, we're gaining heat. So we're actually drawing in more heat from the sun than we're losing to space. But you're talking in the probably about 5 or 6 degrees a day is the variance of it. But we're drawing in about 6 degrees a day because the overall temperature of our planet is staying. I'm just giving you an example because I personally don't know the numbers. I haven't looked into it. I know that it's around a 1% gain in energy from the system that we're getting at the moment.
All right.
It would be a matter of, you can't look at it at degrees Celsius anyway. You'd have to look at it at how many joules within the system is being changed.
Yeah.
In the same way that I presented that question to T-Rock. These are the numbers of how much temperature is being affected at the moment. And with your numbers, it jumps up to this. Please explain.
And then he saw numbers and he shut down.
Yeah. He couldn't even answer the question. It was just the interaction between the lithosphere and the mantle. That's all it was. It wasn't taking into account friction or anything else.
Oh, hey, John brought up a Dave McQueen explanation. Do you know what blobs he's referring to?
Oh, God, no. That was...
I mean, it's Dave McQueen, so it's obviously wrong. I'm just curious.
This involves his example of using a wine glass and a toilet roll.
I'm sorry, what?
he got some Play-Doh from his grandkids and made a basic indication of the way that the the basic Earth is shaped. Then he gave an example of upwelling along vents of what has been bringing up things like diamonds from from the lower lithosphere into the upper crust. That's why we find diamonds around Africa. He then thought that because the system was, see how the neck of the wine glass is sort of a tube. That's the sort of thing that's bringing the magma up from the lower lithosphere into the upper slab, and that's what bringing the diamonds up. Now, if we take this toilet roll holder and put it under a slab like so, that's almost like the system. But instead, we put one slab under another, and that's how we could take the heat from the top down to the bottom. No, that's not how it works.
No, it does. No.
He doesn't
No,
take
no.
into account pressure, temperature variance. It's just it would still be hotter down the bottom than it is at the top, unless somehow the top is hotter than the bottom. That would be the only way the temperature would be going down. So, are you saying that the surface of the Earth was gotten to the point it was 1,000 degrees Celsius, only on that slab before it was subluxed underneath the other slab? And that way is how. Just oh god no! It's
Friggin', I am going to make a video on McQueen, but I know it's going to cause me a massive headache.
it causes me emotional distress.
Just like it's it's really weird because listening to him, I'm not sure if what he's saying is outdated, bullshit, or well, I guess which is more? Which is more? Is it more outdated or more bullshit?
There is the third option, which is more likely.
Which is
All of the above.
yeah. Man, I remember he had a debate against I think it was Snake. Snake was right, I think, a while back. And I sent in a couple super chats to ask him some questions because, he was irritating me. And he, over the span of 5 minutes, he basically said that, scientists don't know what's going on with this one rock formation. It says so here in this book from the 60s. So we don't know anything about Earth history. I looked it up. It's been pretty well researched since the 70s. He just hasn't bothered to look into it in 50 years.
And just so you know, John, there's actually more than two. There's what you could call there's about 16 or 17 very old slabs that can actually be seen near the outer core. And you've got to realize that they're actually not looking at the temperature using that. They're just looking at density, and that's the biggest problem.
I mean, so they're picking up two blobs of higher density sitting right outside the outer core.
Yeah, there's more than that, but when it comes down to it, they're not lower temperature, they're just a different density, and that's all that we can see down there. We can't actually tell the temperature that deep because all we're getting is sound returns. Oh, sound returns can tell us temperature. So by speaking through my microphone, can you tell me the temperature here?
I'm guessing pretty high. You sound a little heated.
No, that's just because I'm annoyed. But it's actually lovely and cool here at the moment. That's a different matter. It's winter.
It hit 90 degrees Fahrenheit here today.
Can't you just use real temperatures?
I wish, but that's the local temperature.
I know. Yeah, the
Right,
blobs and the
about 32 degrees Celsius.
yeah, you've got multiple different ancient plates down there. There are some in the mantle transition zone between the upper and lower, and there's a bunch of them down in the lower transition. So what McQueen is talking about, he's speaking out of his derriere.
Yeah, of course. I think Hillhugger put it well. McQueen is the worst, except for all the others.
No, I would say McQueen is the worst because of the fact being that he has had training in geology, so he should know better.
Well, I mean, like Mark asked us when we did that one stream with him, like, why would someone work for AIG, or why would someone who has training in geology promote the young Earth? I believe it comes down to two options: money or mental illness. And considering his age and how he presents himself, he is probably pretty damn senile.
But if you want to have a better look at that, that's a list of all the ones that we've actually been able to track, and there's quite a fair few.
Interesting. Well, I think it's about time we got back to a glacial maximum.
Well, the one thing now that we've brought out McQueen, he does have one thing in common with glacials.
Oh?
McQueen.
What is it?
He speaks as fast as the glaciers move. I'm sorry, I shouldn't pick on the poor man.
No, I feel like it might be fun.
Just because it's fun doesn't mean it's the right thing to do.
While I do agree with you, I also disagree with you, and I'm not sure how to put it into words.
It shouldn't be done in public.
Fine.
We need to hold ourselves to a better standard than they hold out to themselves, so that's why we shouldn't pick on him.
Okay.
Even if it is true.
But if he calls us liars who don't know anything, can I pick on him then?
Yes, because he brought it on himself.
Okay, good. Just making sure.
This with time, but the ice age is rapid and it starts to end after about 500 years of buildup. Then it has to melt. First of all, you have to figure out how much ice and snow build up in that 500 years. And to do that, I had to figure where the moisture sources were. The main moisture source is the evaporation of the warm ocean, plus movement of warmer air and water vapor in that air from lower latitudes to higher latitudes. You got to figure out how much fell in the ocean versus the land. So I roughly estimated the average depth of the ice in the northern hemisphere is about 2,100 feet. In the southern hemisphere, which is mainly Antarctica, was about 4,000 feet. And then you got to figure out how long would it take to melt this. So I used the equation for the energy balance over a snow and ice cover. It's the same thing.
Okay. I will say you can absolutely estimate how much ice you should have in an area, like how much mass you should have in a glacier, if you know the right math, but I do not believe he has the right math.
And I don't think that what he's actually presenting is correct, because you've also got to take into account the reflection aspect, because he's not showing any reflection of the energy coming into it.
Yeah, he's not caring about albedo at all.
Yeah, he made it up. That's where it comes from, Hillhugger.
Yeah. It's the time he needs out of the time he has. That's why it's 500.
He worked out that it would have been 500 years by using his own mass and his own calculations to come with a very, very warm ocean and a very, very cold continent somehow.
Man, I gotta look this up just really quick. What's the average velocity of a glacier?
That's a tricky one because you've got glacial slips. You've also got different glaciers, depending on the thickness, depending on the angle of it.
But I'm just gonna go with let's say the greatest amount on Google for a normal glacier, which is about 70 meters per year. Let's see. How many meters could we then get in 500 years? 70 times 500. So 35,000 meters or 35 kilometers. Now, Beamsy, I'm not sure if you know this since you're from Australia, but how many kilometers long do you think, or how many kilometers do you think it is from the north part of Canada to the south part of Canada?
It has to be less than 3,000 to make it fit into that math. I know
It has
it's
to
not,
be less
but
than 35.
yeah, it has.
It has to be less than 35.
It might have gotten to It might have gotten to Fairbanks in Alaska. Might have.
I am sorry, sir.
Fairbanks is
You know what? I scrolled down a little more. Ice velocity and thickness of the world's glaciers. I'm not sure. Can I show a public article, or at least it's
public, so yes.
or at least it's abstract. I guess got to pay for the rest of it. But it does say here one glacier in Patagonia moves at about 12,000 meters per year.
But where's Patagonia?
South America.
And where is it? It's right up in the mountains at a very, very high angle. That's why it moves so quickly.
Yeah, it also high angle, super high rate of melting. It goes straight from freezing to South America temperatures. But let me just do the math here. Okay, so those glaciers could hypothetically move 6,000 kilometers in the time we have. Okay, to its credit, apparently Canada is only about 4,600 kilometers from its northern to its southernmost part. So hypothetically, the ice could make it to the United States. And I believe the southernmost reach of glacial activity we have is in Missouri. So hypothetically, if it was going as fast as the fastest moving glacier today, the ice would be able to make it. The problem is that we have estimates for how fast those glaciers were moving, and they were not moving that fast.
No, because it wouldn't have made it that far.
No. I'd have to go back and look, but I think the highest estimates maybe top out at a couple hundred meters per year.
Well, if you give it 500 meters per year, it still even wouldn't be enough. And they would have had to have been there for a long period of time for the Missoula floods events to have actually happened.
True. You wouldn't have had time for Lake Missoula to form. So, yeah, no, just on all levels, this just fails unless the glaciers were walking south.
Same thing, you add up the heating factors for the ice and the cooling factors, and you add them all up and you get a change in temperature, change in time. But in this case, the temperature doesn't change. It stays at 32 degrees. So you can convert that into a melting factor. And it melts about 10 meters a year or 33 feet a year.
Oh, hey, speaking of Penguin Glacier, there it is. I think.
And it melts about 10 meters a year or 33 feet a year.
I think. I could be wrong.
And at that rate, the edge of the ice would melt in 70 years.
This one is in Alaska?
That one I know is in Alaska.
Yeah.
And the interior of Canada being cooler and with less solar radiation would take more time. That would cool in about 200 years.
Antarctica.
So the total time for the
Antarctica?
Yeah, that's actually an area near the Ross Station. I remember that one.
Oh, have you been there?
Yeah.
Okay, you got to tell me the story sometimes. That sounds awesome.
We were there to just do some drilling. That's all it was. It was nothing exciting.
Okay, I don't care. You went to Antarctica. That is exciting.
I live in Australia. It's not like it's that far.
Okay, maybe. I'm from Iowa. Going to another state is exciting to me.
Good point.
Look,
but
you live in a country where everything is trying to murder you. I live in a place where it's just corn.
Is that why everything we talk about is rather corny?
Radiation would take more time, but that would cool in about 200 years. So the total time for the ice age is approximately 700 years.
I am
based on the climatic aftermath of the Genesis flood.
Actually, speaking of witty, what do you think of the new name of the series?
Oh, I didn't look at the name. I just quickly brought it up.
Creation Science Theater.
That sounds interesting. We just need more popcorn for it.
That could be arranged.
Well, we were talking about popcorn basalt, so I think that's where it is.
But it's a play on Mystery Science Theater, if you've ever heard of it.
The sad part is, the only continent I have never been to is North America.
Oh. Well, feel free to come visit. I can take you to all the not-so-deathly boring parts.
Unfortunately, my condition, I can never fly again, so I don't think I'll be going anywhere.
Ah, damn, sorry.
It is what it is, and that's why I've got my icon the way it is.
Oh. Well, maybe we can still find some way. I hear boats still exist.
Yeah, but going from Australia to the US on a boat is just going to drive me nuts. And the crew.
True. Yeah, it could be a Pacific Island tour, you know.
I would regret it, Hilaga. That would have been a great opportunity.
Yeah, I would have loved that. Because, I mean, of course, paleontologist here, the draw for me is fossils. Because Antarctica has, frankly, just some insane fossil deposits that are amazing to see.
Part of me wants the ice to melt just simply because of the fascinating geology we'll find in that region. But then the reality sets in about what would happen if that actually did happen.
Yeah. But, like, here, as an example, this is Cryolophosaurus, the frozen crested lizard, apex carnivore from Antarctica. There's also stuff like Antarctopelta here, a very well-armored ankylosaur from the area.
Yeah, the stuff they're getting out of there is fascinating. You get some of them in the southern parts of... Yeah, you get some of them in the southern parts of Australia, but just not as many as Antarctica.
Let's see, was this one found in Australia? Yeah, it was found in Australia. Okay. This is Leonelinosaura. Yesterdays. Look at this. Look at this fluffy little adorable thing. It's so cute. I want one.
and it will murder you in your sleep, but you'll be happy.
Yes. Probably safer than my cat, to be fair.
Well, here we are at Red Lodge, Montana, in south central Montana, at the entrance to Rock Creek Valley. I've calculated in the post-flood rapid ice age that the melting of these ice sheets would be complete in about 70 to 100 years along the edge of the ice sheet and in the mountainous areas. So that represents catastrophic melting. And when you have catastrophic melting, you have a huge amount of water coming down.
Okay, is he going to try to tie this into Missoula?
Oh no.
I feel like he might try to tie this into Missoula.
We are standing on a glacial outwash terrace from the ice cap that melted over the Beartooth Mountains. When it melted, it sent all this gravel through this area, and you can just barely see the edge of it along that pediment above the city of Red Lodge. You can see the lower part of the terrace over against the mountains there. I should say that's the top of the outwash terrace. As it comes along here at the base of the pediment, here it goes a couple of miles. We're about a good 150 feet above the city here. Later on, it eroded part of it, and that is where the city of Red Lodge was built. There was no lakes ponded that I know of behind moraines that burst. It was just all catastrophic glacial melting, probably rivers half a mile wide, and they'd snake around and they'd deposit this gravel in a big, huge gravel bar that was left flat. And then it eroded after it was over with to form these terraces and in the valleys where the city of Red Lodge was built.
Remember how he was explaining at the start of the movie how these features are formed during glaciation events?
Yeah.
Why is he now saying that it wasn't formed that way and it's now formed by water?
Well, I'm not sure, but oh man, I can't remember the name of it. But there's a type of I guess just call them subglacial streams. Most of what they deposit is gravel, so I'm almost wondering if these aren't from those, because they can be really freaking big.
That's where these are from, and he explained that at the beginning of this when we watched this yesterday, and that's why I'm thinking, you explained this before, and now why are you changing it?
Was he talking about these specific ones?
Not these specific ones, but he was showing how these features are actually formed during glaciation.
Oh man, are they just called subglacial streams?
I can't remember off the top of my head now, but yeah, I think he's preparing to do for the next part, which is the Missoula flood.
Maybe. I can't remember what they're called, but I think what he's describing is something that forms under glaciers, because they're mostly gravel.
Yeah, he's talking about the moraines.
Subglacial moraines?
Yeah.
Okay, maybe I'm just not being able to remember what the specific names are then. I'm not sure.
But the moraines are what forms these gravel features. And the subglacial water actually allows for that depositing. But again, he talked about that yesterday. They would have been outer moraines caused by the tendrils of the glacier coming through, and then they would have breached and created the runoffs like that. But yeah, he's explaining that really well, but then his conclusions don't fit the evidence that he's both presenting and what we can see.
Yeah.
Here we are in the Madison Valley of southwest Montana. This valley is a long north-south valley, similar to a lot of other valleys in southwest Montana, that's composed of mountain ranges generally flat bottom valleys and other mountain ranges. But this valley is different than practically any valley in southwest Montana in that these flat surfaces you see here, which look like pediments, are not. They're glacial outwash material from when the ice sheet in Yellowstone melted. Now, the ice in Yellowstone was up to 3,000 feet deep during the Ice Age.
Mhm.
And when it came time to melting, it melted rapidly and was catastrophic. This Madison Valley.
Okay, I don't think I believe him. I think he's just standing on river terraces that were carved through glacial outwash.
They look more like a river terrace caused by glacial outflow rather than a catastrophic event like he's describing.
Yeah, because in a catastrophic event, you wouldn't get those nice flat terraces, for lack of a better word, because that's what I think they are.
Yeah, let's go to the Scablands and see what a catastrophic event would look like.
Yeah, bingo. Yeah, these, like, I got to see a lot of the Snake River when I was up in Montana. This looks like a lot of valleys that the Snake River went through. And yeah, they formed in that way. It was a glacial river, but then it stopped getting a ton of sediment from the glacier, so it started just chopping down through all the outwash.
Has the Madison River, and the terminal moraine upstream at West Yellowstone is about 50 miles away. And
Sorry,
so when the
apparently my
ice
girlfriend's
melted,
asking.
it probably melted and sent huge amounts of water and gravel that carpeted this whole valley from south to north, forming these terraces all across the valley. Then at other times, the current was too fast and it eroded part of it out, forming the terraces. And then it did it again, and probably again. That's why you have multiple terraces of gravel piled up in this monstrous outwash fan. Another huge outwash fan is in Jackson Hole, north of Jackson, Wyoming, where you see similar gravel
Oh, hey,
terraces.
I've been there.
And a few other drainages from the Yellowstone Park area. You see terraces, but they're a lot smaller than the Madison Valley and Jackson Hole, where the Snake River comes through.
Looking at
Now, there's
that,
probably
to me, that shows that the gravel was piled up due to the moraines.
Yeah.
That would be the only way that you have those original terrace.
Yep.
And then over time, it's almost like a canyon formation because you can see that wonderful meandering river through the middle of it. And I'm
Mhm.
sure that river wouldn't have always been through there because of how flat the terrain is.
Well, no, the river was probably always there. It just wouldn't have been at that height.
No, I'm talking about the shape of it because it probably wasn't always that shape because it was probably shifting as the look at some of the features on there. You can see drainage effects. So it just looks like exactly what you would expect from water draining across a gravel-based bed.
It's just a normal meandering river.
Yeah, and yes, there might have been flood events creating established terraces, but not to the extent of what he's talking about.
I mean, again, I think he's just wrong about the flood events causing these, other than maybe an initial one.
No,
'Cause-
it wouldn't be a flood event that caused it. It would actually be a combination of the moraines and the subglacial lakes that would be building up and building up and building up underneath the.
Okay. I get what you're saying now.
Yeah, because the glacier would create a terminal moraine, creating a dam. So
Yep.
then the subglacial water would actually be bringing gravel and hitting the moraine. Because it has its own natural dam, and that's where all this came from.
Yeah.
But that would take a great deal of time. It wouldn't
Time
happen.
he doesn't have.
And the only way that sediments are deposited are in slow moving water. If you're talking about catastrophic water, what does catastrophic water usually do to solve sediments? Yeah.
Off and away. But yeah. Like maybe just to kind of explain what I was talking about, the river down cutting. So when water flows, it will take away from its bed and it'll deposit onto its bed.
John, you
And
won't
then,
actually find fossils in this sort of locations because these are mostly gravel deposits. They're not actually anywhere that you'll find fossils. You could dig for decades and you won't find a fossil in this sort of area. This isn't where you'd find fossil formations.
that said, like an animal could be caught up by the flood and buried and everything.
Not in these sort of formations, not on those sort of
No?
flat. Yeah, you might find it where the river is, but not where all that flat area is to the north of the river.
Anyway, when you have flowing water, it will erode its bed and deposit onto its bed.
But only on a slow moving.
Well, no, it happens in fast moving rivers too.
Not to the same extent, though.
Eventually, it reaches an equilibrium.
Yeah.
And then there's a bunch of different things that can happen where it'll either start depositing more, usually, yes, if it slows down, though it can also happen if it just gets a crap ton of sediment and just can't hold it all.
You'll find also that the fast-moving rivers are usually seasonal, so that's where we start getting valves. But again, that's more.
Yeah, because they'll surge occasionally.
Yeah, you'll get surge, slow. I'm trying to think of any fast-moving rivers that are always fast-moving, but I can't think of any. All the fast-moving rivers I can think of are seasonal or ones that have been created artificially.
There are mountain streams that'll do it. They're usually fed by meltwater, though. But anyway, back in time, this river probably originated from the glacier. But since glaciers churn up a ton of sediment, it was pretty choked up, most likely, and was at about the same level as this plain here. Then, once the glacier either fully went away or started to move slower, it had a lot less sediment, so it chopped right down through the initial layer until it found a new level.
What would have actually been more likely if you look at the features of it, because you can see on the very upper right area of the screen, see where you've got that light green and slightly brown area of the mountains further north.
Right here?
See that a bit further north, just not where the trees are. See that outcrop, that little hill there. See how it has the light green and the brown, the hill that runs from where the cursor is to that lake?
I think so, yeah.
Yeah, that little hill there would have been the edge of a glacier. The glacier would have probably been to that height, and it would have been wrapping around that entire area. All that brown would have been the subglacial flow of the water. That entire area would be where the water was flowing underneath the glacier, depositing gravel until it reached the terminal moraine and basically damming up, creating all that brown area. The area where the river is would have actually been caused during the melt-off.
Well,
it's a lot more complex. If I could show you, I could explain it much more detailed. But that entire area there would have been under a glacier, except for that area up in the top right of the screen. That would have been the extent of that little hill there.
Potentially.
Yeah.
I agree with what you're saying from the view we have here, but I do feel like if we could actually go there and examine the sediments, we might have a different opinion. But at least from what we can see, I do agree with you for the most part.
Looking at the features, you can tell that entire brown area would have been under the glacier, same where the river is. And that's where all that gravel would have come from the subglacial water flow, because it would have actually terminated at the terminal moraine. So over the 1,000 years that the glacier was sitting on top, that's where all that gravel came from.
Are you saying like this right here is a terminal moraine?
No, the terminal moraine's further downriver.
Further down. Okay.
And he told us that there is a terminal moraine a couple of miles downriver.
Oh, okay. Sure.
So I'm going on the information that's been given, which is a couple of miles down we can find the terminal moraine, as you cannot see a moraine anywhere there, and the extent of that would have been from that small hill there, and that's why that entire area from that small hill all the way south would have been covered in that brown gravel. And as it melted off, that's what would have dug out that area, because where the river is the easiest part for it to flow, and that's why it's got that large plateau of gravel land.
Oh, okay. I see what you're saying. So
that's what the features are screaming at me from what I've been told and what I could actually see, and understanding how that would have actually been. Like that entire area would have been under a glacier, and that whole area would be quite flat and would have actually have built up over time. Then as the glacier melt, because the path where the river is the path of least resistance, that's where most of the flow would have actually been, and that's why you've got that defined cutting where you can see of the drop off.
Sure. I think I was maybe mixing this up a little bit with the previous valley, because I was interpreting all this as an original floodplain. But looking again, I'm not sure I see any like old oxbows or river cuts or anything.
No, that's why I can tell that it would have been deposited when the glacier was over the top of it.
Okay. I'm curious what caused all this mess, but that could just be glacier weirdness.
It also could have been eroded due to storms, because it is in the right area for that sort of stuff.
True.
And a couple of thousand years of storms can really affect it. But if you look to the right-hand side of it, you can see just how uniform it is.
Yeah, that is very smooth.
That's why it doesn't look like flood deposit to me. If the entire thing was pitted and damaged, like you can see on the left there, I would lean more towards a flood deposit, but that looks more like it was actually deposited by some glacial deposits over a very long period of time.
Okay.
Because, like I said, this is relying on the information that he's presented. So it's relying on that there's a moraine further downriver. So there would have been a dam so the subglacial water would have been building up in this area, causing the gravel to build up over this area. And then when the moraine finally broke, because it's got a glacier on top of all this gravel, it wouldn't have actually washed it all away. Hence why it's still there.
Sure. Oh, and also, John asked earlier, yes, there will be an exam. Make sure you're paying attention. I know you're driving, but make sure you take lots and lots of notes.
Yeah, this is the advantage of being a stratigraphist. You can look at features like this and explain to it how it actually formed and where it comes from. And that's why I can tell you this is how it formed based on the information that I have. I would actually have to go and examine it more closely to say that this is most definitely. But based on what he said, what it looks like, and my understanding of the way these features work, I am 90% confident that all this was formed underneath the glacier whilst the moraine had built up a dam.
Sure. And I agree. I like Google Earth, but I also like to be able to be there and analyze it firsthand.
That's why I'm not 100% confident. Yes, you're correct, Bill Hugger. That's why I'm just trying to keep it simple for people to understand rather than using terms.
Yes, this was made by the glacier, not the river. This was made by the river, not the glacier.
No, it was made by the river from the glacier, so they were both made by the glacier.
Okay. This was not directly carved or produced by ice. This was produced by erosion from the river.
Yes.
Can we agree on that?
Yes.
Okay. Now let's get back to tearing him a new one.
Jackson Hole, where the Snake River comes through. Now there's probably about 200 feet of gravel, cobbles, and big boulders that came down when it melted. Now the big boulders probably came down in icebergs with ice floating in the water because a lot of them are angular, so they didn't roll around. Some are sub-rounded.
I mean, they could have also just been broken up and carried in the ice or on top of the ice.
Which is more than likely. The rounded ones are normally carried further and then dumped by the glacier. Then the other ones are usually ripped off, and then as the glacier retreats, then they're usually just dumped where they lay.
Yeah. They could have also had rounded sides. They've just been broken.
And why is he showing the ones on the plateau and none of the ones in the valley? I wonder why.
I mean, I'm pretty sure this is on
Came
the
down in
side.
icebergs with ice floating in the water because a lot of them are angular, so they didn't roll around. Some are sub-rounded.
Yeah, this is one of the sides of the.
That's what I said. Why is he showing them on the sides and on the plateau? Why not on the bottom, where it would actually be more supporting for his evidence?
Well, here we are in Cody, Wyoming,
Hey, I've been
in
there
front of
too.
the Shoshone Water Gap, and we're standing on glacial outwash terraces from the Yellowstone ice cap that was about 3,000 feet deep, that melted rapidly late in the Ice Age. It was so catastrophic, it sent huge amounts of water with boulders coming down through Cody, Wyoming, and it formed a series of terraces, approximately 3 terraces up to maybe 150 feet above the river. And we're standing on probably the lowest terrace, but out in the background you can see several other terraces.
Do we agree these are probably river terraces too?
They would have been formed the same way, but because the ice ages weren't consistent, because sometimes the glacier advances, sometimes the glacier retreats.
Yeah.
So what would create 2 or 3 terraces with advancing and retreating glaciers? The same thing happening more than once.
Oh.
Yeah. It's just the first terrace would have been laid down, then the second one either on top of it or it would have been carved out further. Again, you'd have to go see the features. I don't know which way it would have been done, but this is one of those things that I'll have to analyze myself to get out there, see where the cutoff is, see where the draining events are. This one would be a lot more complex to answer, and I can't just give an easy answer because, unfortunately, there's not one terrace that just goes, okay, this one's easy to explain. This one's a little bit more complex.
Yeah.
Because it could have been the bottom terrace was laid, then cut off, then the second terrace was laid on top of it, then a third terrace, or they could have all been up to the third terrace's height and then gradually cut out as different events were happening. But again,
I would have to go and see that. I feel like what you just said is unlikely.
It's but there are different ways that it could have been. Like it had all been laid at once, or it could have been one terrace and another terrace on top, and then another terrace on. It would just have to be one of those things of going, okay, how did this one form? Because we're aware of the way the terraces form, but we'd actually have to see where they are actually linked. You'd have to drill down into one of the top tiers to go all the way down to see if it's actually 3 individual terraces or if it actually is one terrace and then cut out.
Right.
Just give me a week or two on site and I'll be able to give you an answer.
Yeah, like I feel like this is something people don't usually get with geology. Like pictures are great and all, but it's a whole different story when you're actually there and you can see it with your own eyes.
Some of them are easy, some of them are not so easy, and that's the problem.
Oh, true, but I'd argue a lot of them are easier. Like you can help distinguish, oh, these two things are very alike, but here's the defining detail that allows me to tell them apart that I can only really see in person.
Oh yeah, that's why I was explaining the difference between what how the terraces are at the moment, because yeah, they would have been laid down very similar, but the events that they were going over of their formation, I can't tell you because I have, without drilling and looking at the actual features in the area, I could never tell you. A picture does not do anything for me.
Yep. So that said, I do agree with Hill Hugger's assessment. That's what I think they are from what I've seen.
Yes, that's what I said. I cannot give you an answer for it because how many answers could I think of?
Sure. There are
One,
multiple
two,
things it could
three.
be, but that is what I feel personally is the most likely.
Yeah, I can give you 7 different answers for the possibility. The most likely is the river terraces. But again, how wide are they? How vast are they? How large is the canyon? How large is the valley? Where are the moraines? Yeah.
Yeah.
These are all things
like-
that we don't have information of, and that's a picture won't tell us this.
And that just makes me think of Mark's debate with T Rock the other night, where T Rock just kept saying, "Oh, well, this looks like this. Oh, this looks like that." Let me show you 4 different theropod dinosaurs, and you tell me which of them is more closely related to the others. Then I'll show you that they're all the same species. You just don't know what you're talking about.
Even better, the ichthyosaurs look like a dolphin, and a dolphin looks like a shark. And are you saying they're all the same thing, even though one's a reptile, one's a cartilaginous fish, and the other one's a mammal?
Yep. Like, like here, I could just show him this picture right here. Like each of these individually and ask him what they all are, and I'd probably get all different answers, but they're all the same dinosaur.
Yeah. But again, Hillhugger, both me and Dino agrees with your tertiary assessment of it because that makes the most sense.
Side note, this picture is kind of cool, though I think the adult's a little too fluffy.
Yeah, I don't think they were that fluffy because they said that from what they've analyzed, they would have more quills than actual feathers.
There is some debate.
There is a massive debate about it because
Oh, massive. I almost wrote debate. But the Tyrannosaurus in Prehistoric Planet, if you've seen it, is like genuinely possibly one of the most accurate ones ever put to screen.
yeah, because as you can see, it's got quills and just slight
Very
downing
small
effect.
bits of fluff.
Yeah.
Whereas
I would agree
babies
with that.
are nice and fluffy.
Again, I would agree with that because again, it makes sense from the evidence of what we have. But the adults could also be fluffy. We don't fully know because we don't actually have.
We don't know for sure, but just knowing their environments, their metabolic rate, and a lot of other things, we can make a pretty good guess.
Mm.
And it makes the most sense for Tyrannosaurus rex for the adults to be very sparsely feathered if they had any at all.
Yeah, it also makes sense.
Juveniles would almost certainly need it.
Yeah, taking into account of their closest living relatives,
Yeah.
the young start downy and then they progress into their adult feathers, and that makes a lot more sense. That
and then they grow into this chonker, which is like 8 to 10 tons. Like gigantothermy alone, you don't need much insulation.
Mm.
And hence why modern elephants only have a very, very sparse coating of hair. Because they don't need it. And if they did have hair, like even when they were babies, they'd probably overheat. Anyway.
Here we are at Lake Roosevelt, which is dammed by Grand Coulee Dam in north central Washington. This was the site of Glacial Lake Columbia during the Ice Age. It's about at least 1,000 feet higher than Lake Roosevelt. And it was dammed by a lobe of the Cordilleran ice sheet. It's called the Okanagan lobe. Came down the Okanagan Valley over there and blocked the Columbia River, creating a huge lake in here that backed up clear east past Spokane. Now, the Okanagan lobe is part of the Cordilleran ice sheet that covered much of British Columbia. This lobe probably started in the mountains probably because of the warm onshore flow of moist air, probably kept the lowlands unglaciated for a while. But as time went on and the oceans cooled, it went from the mountains to the lowlands and filled up practically all of British Columbia. And then east of the Rocky Mountains, we had a second major ice sheet called the Laurentide ice sheet.
Yep. Hey, look, my home state and the glacier that was on it.
Yeah, like I said, he's expressing a lot of good information, but
then he
his
just sneaks little things in there that have nothing to support them. Like he brought up again, the lowlands probably weren't glaciated.
Sheet, and it covered central and eastern Canada and the northern United States. And they believe there might have been another lobe in northeast Canada. Now, other locations like in Europe and Asia, there was an ice sheet in northwest Europe and northwest Asia, including northwest Siberia. This one probably started in the mountains of Scandinavia and other mountains because we still had a lot of warm onshore flow because of that warm ocean. Then it worked its way low down and then probably worked its way south. And also over mountainous areas in the world, we had ice cap. So other mountains in the Rocky Mountains were glaciated. Even in the northern Arizona, the San Francisco peaks were glaciated. In the southern hemisphere, Antarctica was glaciated. Probably glaciated starting in the mountains there and just filled in the lowlands and moved to the ocean in Antarctica. Same thing in Greenland. And in the tropical areas, all the main mountains that are pretty high had glaciers on them. Some have glaciers today. And we know that the glaciers were 3,000 feet lower in the tropical areas. So it was a worldwide glaciation. 30% of the land was glaciated compared to 10% today.
Is it as high as 10% today?
Yeah, it's about 10% because it still covers but they also take into account the Arctic ice sheets of how far it actually progresses, as well as permafrost.
True.
Ever since the Great Ice Age, we've had just little tiny oscillations in climate. We had what's called the medieval warm period from about 800 AD to 1200 AD, where the Vikings settled southwest Greenland and farmed, and where they grew grapes in England and other plants grew in England that don't grow today. And then from about 1200 to 1400, we had the start of what's called the Little Ice Age. And this was a dip in the temperatures, of which practically all the glaciers in the world advanced. Some of them covering up towns or parts of towns in Switzerland, for instance. And then the Little Ice Age lasted to about 1880. And then since then, glaciers have been receding steadily on the average to this present day. Now, the cause of the Little Ice Age is very likely long-term oscillations on the sun that we can...
The good old solar maximum, solar minimum. I just cannot get how someone can be just so dishonest that he can present all the information factually incorrectly, and then it's like 1, 2, skip a few, 99, 100. I haven't actually heard anything about meteor impact on the Laurentian ice sheet. I wouldn't put it past it. It's about right. It's spelt well enough that I know what you're talking about. The one on the east coast of the United States. And everyone should know how to spell it. It's spelled IT. I'm sorry, I'll go back to my naughty corner. When you think about it, though, I wouldn't put it past it that there would be a meteoritic impact of it because it wouldn't leave very much evidence. It wouldn't have been something sizable. Hmm. Now you got me thinking about what would actually happen with that if something sizable actually did that. Because you could have at least a couple of 100 meters of it. Yeah, you would have deposits of it because there would still be sediment left over from the impactor itself. But then taking into account that most of the ejector would be ice and it would have cushioned a lot of the blow.
I am back. Sorry about that. I had to take care of something.
It's all good. Remember to wash your hands when you were done.
It was something else.
It doesn't matter what the truth is. I'll just make up my own.
Sorry, meteorite impact on Laurentian?
Yeah, it was the one on the East Coast.
The Laurentide?
Yeah, the big one.
Okay. Huh. I have never heard of that, but if so, that's interesting.
Yeah, I'm starting to think about how you could find it, but it would be very difficult to actually find any real physical evidence other than probably some sediments and some craters that would have been from the ejector of the ice itself.
I guess it depends on how thick of a glacier it would have hit and the size of the meteor, but there'd probably be maybe some chunks left behind, right?
Yeah, there would have been some evidence, but it would be very difficult to find, and that's why it would be curious to.
Interesting.
Because when the impactor would have hit, itself would have actually created some layers within the sediment. Then the ejector itself would have actually left some marks itself because you've still got a lot of energy coming from that.
Mm-hmm.
But what's underlying the ice sheet wouldn't really be affected by it because it would create a lot of cushioning effect due to the incompatibility of both water and ice.
I'm actually kind of curious. Would the hitting ice have helped it not vaporize on impact?
No, it still would vaporize because of the sheer magnitude of the forces you're talking about.
Okay. The glacier wouldn't like melt on contact and provide a cushion.
It would probably be very well researched with the American thing, but as I did most of my research in Australia, I don't actually know much about that. And to me, it's just fascinating.
It'd be really neat to see.
Yeah.
Oh, maybe we can look into that later.
Yeah, that would be definitely something I'll do in my own time, just simply because now he's got me interested in it. Because my brain is
correlate with long-term sunspot cycles.
Go ahead.
My brain is going through how that would actually work and what sort of evidence you would find.
Cycles. For instance, at the peak of the Little Ice Age, it was during what's called the Maunder Minimum, which was about an 80-year period around 1700 where there were hardly any sunspots. And the way it works is the fewer the sunspots, the cooler the climate. There's a strong correlation. So, and we've been observing sunspots since 1610. So we had this Maunder Minimum where we had maybe 40 sunspots in an 8.
Okay, why is the music so climactic right now?
I don't know. I don't know why he decided to put the epic music on.
Like I feel like I'm watching the final battle in a fantasy movie. And he's talking about sunspots.
Yeah.
Which, granted, they are pretty cool, but ill-fitting?
An 80-year period when we should have had 40,000. Why? Not sure. It's forces on the sun. And this was the worst time of the little ice age, was during this. Superimposed on these long-term fluctuations due to the sun, we also had a lot of volcanism, and the volcanism would cause short period coolings that would cause the glaciers to advance even faster. Then when there's little volcanism, we'd have a warm period. So the little ice age is strong correlation with long-term changes on the sun. Same with the medieval warm period, is probably a period of a lot of sunspots. Since the late 1800s, we've had a lot of sunspots, and we've generally been in the warmer cycle of the sunspot cycle.
Okay, now tie it into global warming. I dare you. Okay, I guess he's not. But fortunately, a lot of stuff there was.
A question always comes up of how many ice ages were there?
So
they used to say there were 4 ice ages,
as this goes along.
And this is based
5 major
on
ones.
an analysis of the glacial debris in the central United States, central and northern Midwest. And then when they thought there were only 4, they saw 4 everywhere, or 3 or 5 or something like 4. If there's only 3, it got.
Okay, and then he said that. There have been a lot of ice ages.
There's been 5 major ones and a lot of minor ones. That's
Yeah. Like, again, here in the Midwest, since he's talking about it now, I can talk about it without sounding narcissistic. Anyway, here in the Midwest, yeah, glaciers got down here. I wouldn't say fairly often, but like especially like Minnesota and Wisconsin, like so much of the sediment up there has been reworked so many times it's almost impossible to tell which glaciation it belongs to. Even here in Iowa, like you have a ton of older glaciations that have just been buried by subsequent ones.
I don't even think he knows what that is, Hillhugger.
Yeah. Well, hey, you never know. Maybe he'll name Milankovitch and get it wrong. Or maybe he'll say scientists assume it's this long, but it's really this long because that's how long I need it to be.
I assume my penis is 12 inches long, but it's really only 2.
It got missed one time, they would say. It was kind of like a circular reasoning where they saw it everywhere. And in fact, even though the concept's been dead over 30 years, it still is in some museums.
It's not, though. You're just saying it is, but it's not.
How is the concept dead? Because it's now even further supported by saying that we've had 5 major ice ages and lots of minor ice ages, and some of those ice ages had ice ages.
Yeah, here, let me see if Google actually has a good map for this.
I just like saying meteorites and impactors. That's the easiest way I put it, because sometimes comets do an impact as well.
Right. Here. You know, we'll just stick with Iowa for now because it's what I'm most familiar with and it shows it pretty well on its own. Can you see my cursor?
Yeah.
Okay. So first off, everything here is basically all glacial sediment. You have a few rock outcrops like on the eastern edge and a few on the western edge and some little dots in the center where rivers have cut down. Other than that, all glacial sediments. And here you actually have distinct areas where some glaciers went farther than others. As an example, this is pretty well shown here. Most of the green on this map, as well as up here, was only really touched during one glacial event about 500,000 years ago, I think. A lot of the yellow and white was only touched by a later glaciation. It also touched over here, but then that was buried by another glaciation event that caused this big old footprint right here.
But do you see how there's 3 distinct layers within that?
At least 3. The thing is, a lot of this, again, has been super reworked and reburied.
But just from what I can see there has been at least 3 incursions by a glacier there.
Yep. And this is just one state in the Midwest. It's not even touching the Great Lakes, where a lot of these glaciers came from.
Yeah. Do you see where the big sort of red cross is just below your cursor, down to the left?
Right here?
You can see just the edge of that, just the edge of a moraine. Just it goes all the way to the. See how you can see the curve in the feature there?
Going up here?
No, it goes directly left from there, and you can see it going towards the mountain there. Yep, that, and you can see it curving up, and then curves up the other way.
Yeah.
And then north of there,
I think maybe I see.
It looks like a very, very old moraine there, and then
this right here?
Yeah, that looks like 2 there because you can see
these 2 are part of the same glaciation. It's just the glacier stopped here, retreated, and then stopped here for a while.
Yeah, but that's what I mean. There are 3 distinct areas, and then it looks like from there, the glacier has been advancing 4 times. But
and there's a ton of really old glacial valleys up around here. Like really old as in it's hard to recognize them as glacial valleys unless you know what you're looking at.
But from there I can recognize where there's been 1, 2, 3, 4 advancements and the retreatments, because the very bottom one, the one where I showed that star, which is just a very faint outline of an edge, that one looks like a very, very old one. And then the 3, which you can see north of there, which are very well defined, look like just from one feature.
Yep. And again, this is just one state. Let me see if I can find one of Wisconsin.
But that's why I said just looking at that.
Wisconsin's very, very hilly
and washed out.
Yeah, a little bit.
But just looking at with my knowledge, I could see those those different advancements and where they were treated, and I could tell that 3 of them were actually just from one event because they're all as well defined as each other.
Yeah, there's a big one, or a bunch here, actually. There was a lot coming in from this area. I think it was the Green Bay lobe.
Yeah, it's a lot more difficult to actually see. I can only see one moraine from there. Well, one very well-defined one.
I think there's another hint of one up here.
I can see a hint of a smaller one.
Maybe here and here.
Yeah, really looking closely on the right-hand side in that green area, I can see 3. I think 3. I know I can see 2, but I'm not quite sure about one of them.
Yeah.
In the brown area, I can see 1. Just 1. I can't. It's just very difficult to actually see because, again.
Yeah. And here's Minnesota, where many more of them came through. So down here is Iowa. You can see a lot of them just came right through here, straight south.
Yeah, I can't see any. I can see an edge of a moraine, but I can't actually see any.
Yep. There's a moraine here, some here, and here.
Yeah, I can see edges and under, but I can't see any terminals.
Yeah. Well,
I'm just looking for terminals.
Just came through here.
Yeah, I'm just looking for terminals to give a bit because they give a better, more defined feature. It looks like a thumbprint.
Yeah, that's fair. That's fair.
But I can see where the edges are, but I can't actually see any terminals. It's easy to see them in false color than it is in black and white. But
yeah, true. Point being, I guess, he is just flat out wrong. Like, there's been a lot of glaciations, and we can see them really easily.
If you know what you're looking at, then that's the problem. Because people who don't have an understanding of geology can't just look at a feature and go, oh, that's actually from that. That would be fascinating to find out where it's from. They go, oh, it's rocks in a shape.
Yeah, that's always irritated me. I hate it when they do that.
No, people have different interests, so you can't be
they
expect
do.
everyone.
Like, just growing up in a small town, people really belittled my interest in geology a lot. So it built up an innate dislike of that mindset, I guess you could say.
Whereas I couldn't give a rat's ass.
I've been made fun of it my entire life.
Oh, at least you know how to get your rocks off, so that's one thing.
And here we go.
Now they realize that when a glacier forms and moves, it tears up the previous ice ages, and so you can't really tell. So now they say we got to go to the ocean bottom.
Okay, there he actually said a somewhat true statement. If a glacier goes over where another glacier was, it tends to destroy or bury the evidence.
Hell, that just comes down to the aspect of gaining knowledge is a wonderful thing to do, even if it's something that you don't have an interest in. That's why I listen to most people. But if it's something I have a great deal of knowledge in, if something is literally being lied about, it just...
Yeah.
No!
Like, I don't know anything about engineering or most math stuff, but I find it fascinating to learn about.
You're going to have to brush up on your maths a little bit when you get into some of the more advanced parts of geology if you're going to go into it.
Yeah, when it comes to geology, I have most of it down. If I sit down and pay attention to it, it's when math starts getting really weird that I start
Some of
losing.
some of the things in the more advanced aspects of seismology and stratigraphication is very weird because you're working with some very advanced chemical concepts.
Yeah, but like if you want me to calculate, say, sediment deposition rates or bed load of something, like I can calculate a lot of that stuff pretty easy.
But when you start getting into the aspect of the lithification effect due to temperature and the variance on depth, it starts getting a little bit weird.
Agreed. Like if you sat me down and had me focus on it, I could probably work through a lot of it. But
My
like,
advice is get a cheat sheet. Get a small little cheat sheet and laminate it,
Sure.
and then that will help you.
True. And something got slammed there, and I agree.
It was the door.
I do agree with the cheat.
The door was open for the cat to come in and out, and it's all right. She's sitting next to my feet.
Anyway, yeah, I agree. Cheat sheets are very helpful.
Yeah, when you get into, if you start continuing your studies into geology, I advise a nice little A5 or A6 sheet with some of the more advanced formula on there, and just get that laminated so it fits in your pocket.
I didn't laminate it, but I did do that.
You'll be using it a lot, so it's good to get it laminated.
Okay, fair point.
It's just a little piece of advice if you want to continue it.
Yeah, I appreciate it. Like, what I kind of like to do is I like to have like a full-on notebook and just organize it out as much as I can, so it's really easy to find. Oh, here's this equation. Here's what it can be used for, and it's related to these equations that can be used for these things. If that makes any sense.
Yeah, you'll still have your notebook and journals, which have more in-depth knowledge of it, but there are some formula that you might have, okay, I know about 80% of this, but this formula is going to drive me nuts. Okay, I'll just put that down just to remind me of saying that this is its name, this is what it looks like, and these are the constants that I need to work with, and then going from there. That's all you need to put down on the cheat sheet.
Yeah, that's fair. That is fair.
To determine the number of ice ages. So they take these deep sea cores and they core the bottom of the ocean. They bring it up and they analyze a number of variables in it. The percentage of carbonates, also the percentage of a certain isotope of oxygen.
Here, wait.
Also the percentage of...
I'm not certain, but that guy looks very familiar.
I'm sorry, I was looking at the device and I just remember playing with those sort of things, and it's sort of memories.
I only got to do it once or twice in my undergrad, but it was really neat. But I remember the first time the technician explained to me how it worked, and I just stood there freaked out. Like, is there a chance this thing could explode?
Yes, why do you think it's so heavily built?
Yeah, hey, I was new to the sciences, and I was just like, But yeah, this guy looks familiar. I'm not certain I know him, but he looks familiar to me.
That's usually used to break down. And that thing is usually used to break down samples into its basic isotopic components, so that way you can get an analyze of what it's made of. Just so for the layman, just in case.
Yeah. It's a. How did I forget the name of it?
The name's sitting at the end of my tongue as well, but it's got heating elements, lasers, and it's got reading elements. It registers the gas that comes off of the sample.
Spectrometer?
Yeah, that's it. It's a mass spectrometer.
Yep. There it is.
Isotope of oxygen. They do this ratio of oxygen 16 to oxygen 18, and they analyze this down the core. And it wiggles like this, it's high and then it goes low, high, low. And down the core, they get multiple oscillations. In fact, up to 50 now. And they claim that the cause of those oxygen oscillations is due to the interglacial cycles on land.
No.
And so they claim now there's 50 ice ages in regular succession in the last 2.5 million years of uniformitarian Earth history.
No.
The last 800,000, they were separated by 100,000 years. Before that, they were separated by 40,000 years. You might wonder, why is that? Well over 60 theories, they decided they're going to believe in the astronomical theory due to the orbital.
Okay, he's not going to explain the isotopes.
Yeah, when water is cooler, it is able to hold more oxygen, and therefore the sample of oxygen would be increased due to the ionization effect of the salt on the sediment, therefore bringing it down to the sediment. So you could see that, okay, at this stage we had more oxygen in the oceans, and therefore it would have been cooler. That's all that they say.
Wait, sorry. Could you? Sorry, I was looking something up. Could you? What did you just say?
Because of the way that sediments are formed in the ocean, because it's usually due to the ionization effect of the salt on the sediment, it also traps some of the oxygen elements that are in the water. The higher amount of oxygen is due to the fact that the oxygen saturation of the water is higher due to a lower temperature. And that's all of those are telling us. They're not telling us that, oh, that was an ice age. No, we can see the fluctuations on the amount of oxygen in the ocean, and therefore we can tell you that, oh, the temperature was higher or lower at that stage. Massive spikes might lead us to the conclusion, oh, that's the possibility of an ice age. But there's more than one thing that causes an ice age.
Okay. Yes. It can also give you a rough estimate of when sea levels are lower, though, right? Because the concentration of O18 will be higher relative to O16, because O16 evaporates preferentially.
Yes.
Okay. Yeah, I paid attention in isotopes.
Yeah, it's the combination of those two that gives a better idea. So if there is a higher rate of O16 and a higher rate of oxygen overall, that leads to the possibility that it was an ice age. But right there, it's just telling us the aspect that sea levels were slightly lower, which multiple things could cause, and there was a lower temperature. But again, multiple things could have caused.
True. But then again, we can also match up those times with what we have in the rock record and glacial deposits.
It's more than just one piece of evidence that actually say that
it's
something
more than
was
one
an ice
piece
age.
that comes together. He's making it sound like that's one of the only pieces of evidence we have.
because using just that data, we can say that there were hundreds of ice ages over the history of the. If you make the assumption of that if it's below a certain point, then it's an ice age, but that's making an assumption. That's only one piece of information it's one piece of the puzzle. It's like taking a piece of puzzle and saying it's a Taj Mahal when it's really a picture of Big Ben.
Mm-hmm. Yeah. We have 10 puzzle pieces that we put together to make a picture, but he's picking on the first piece on its own and saying that's all we have. Also, Hill Hugger just brought up rocks and soil under microscopes, so I feel like I should show a certain thing.
Yeah, every part of it, we all do it because it gives us.
Behold the gay mineral. Happy Pride Month, everybody.
It's calcite. It's lovely.
Yeah, it's so beautiful. I love it.
Some of the calcites you get to. There we go. You found it.
Yep. So this is something called cross-polarized light, or these crystals are put through cross-polarized light. And when you do it with calcite, it turns into a rainbow.
See if you can find shock quartz.
Shock quartz under polarized light?
Yes. There's some small ones on the left-hand side there. Oh, there we go. Bottom right.
Bottom right?
There we go.
Really? Shock quartz gets like this?
Yes. That's shock quartz.
Interesting. Correct me if I'm wrong, but isn't quartz usually under cross-polarized light either like white or black?
Shock quartz is actually caused by large events, normally through impactors.
Yeah,
so
like
when you come up,
impacts.
Yeah, so depending on the scale of the event, some of the shocked quartz really looks very pretty.
Huh. You know, I have never had the opportunity to look at it, but that is pretty. I do agree. What is interesting?
That's due to its cutting as well. That's a little bit different.
Yeah.
It's more of a prism.
Are diamonds cubic? I forget what kind of crystal diamonds are.
No, they're not. They're
not.
pure natural. They're pure crystalline structure. So that's actually more due to a prism effect rather than the actual light.
Well, I was meaning the shape. Oh no. My brain. Like the structure of the atoms in the lattice.
They're cubic.
They are cubic. Okay.
That's why that coloration is due to the way it's cut, creating more of a prism effect than the actual diamond itself. But that's why I like shock quartz, because it surprises a lot of people just how pretty it is.
Yeah.
Like
it reminds me of some metamorphic minerals I've seen.
There you go. See the ones on the very middle of the screen there, the ones that you just scroll down to. Those ones. Those ones are actually particularly from the Chicxulub event.
Really? You recognize them from the Chicxulub?
Yeah, because of do you see the shock quartz that it showed up earlier? The first one? Do you see how it has multi-directional lines of fracture? I
believe so, yes.
Well, you can see it on the left-hand side of your screen there. You can see how it has multiple different directions of... Yeah, see how it has multiple...
Yeah, definitely.
That tells you it was probably from a smaller meteorite impact or a volcanic eruption.
Before you say why, I'm going to guess because a higher degree of impact would cause all the fractures to be in a single direction.
Yeah, it aligns them.
Okay. So, yeah, from something really big. Okay, cool.
Yeah, so VEI of 7 or higher, or a large impactor event causes stuff like that. I know that particular sample is from the Chicxulub, simply because I've seen it before. I've seen that exact picture.
Ooh. Hello there. Man, Yeah, sorry, I could look at stuff like this all day. They're just. I was. Petroscopy is an amazing class, and I love it. Or petroscopy, petrology. It was called
Petroscopy.
petrology.
Petrology is when you're actually digging the stuff up. Petroscopy is when you're actually looking at it under the. What is that microscope called? It's not called a microscope. It's.
It is a microscope. I forget the exact term.
It's actually got a specific term for it to describe the crystalline structure. And I'll be muted while the background sound's going, so
Sure.
you can start the movie for a bit more.
Sure. I guess I will say, at least in my class, we just called them the microscopes. We never called them anything other than a microscope.
Orbital changes in the
From
geometry of the Earth going around the sun, slight changes in the orbit, it'll be a little flatter. The tilt of the Earth changes a little bit, and the precession of the equinox, they call it. It just changes the geometry of the Earth-Sun relationship, so that you get a little different sunlight in different areas. Because of these changes in the geometry of the Earth, the amount of sunlight varies seasonally and latitudinally. And when you get low solar radiation in high northern latitudes, that's supposed to be correlated with ice ages. And when you get more sunlight, it's correlated with interglacials. So this is how they do it. And they make these cycles up, and they fit everything into these cycles because they believe in the astronomical theory of the ice ages. And it's these deep sea cores that they claim is evidence. But there's a lot of variables associated with these interpretations.
Okay, he says we just make them up. No.
Yes,
So-
and there's more to it than just what he's describing, because sometimes there's more ocean, which reflects more sunlight, which creates a cooler climate. There's also sometimes that there is areas in which you've got larger ice areas, which again reflects more sunlight. There is more to it than just one or two things. Like, you could be in a solar mini time, but in a time in which,
have fun blowing up, Adam. I'm gonna get another drink.
yeah, you could be in a solar mini duration in the sun, but both the orbit and the oscillation of the planet could mean that it is consistently warmed up in there. And also there could be a large chunk of land stuck right in the middle at the same time. That would create a large heat sink, and that would create less of an ice age. There are so many different factors you need to take into account of what causes an ice age. Yeah,
Kitchen, I agree.
but the idea of going, ooh, pretty crystals, look at the trees, that was just more of an aspect of curiosity, because stuff like the shock quartz and the crystals are fascinating to people like myself and Dino, because we understand where they come from and how they actually they come into effect. And the device we use to looking at them is a microscope with extra bits. So it's not really called a microscope. It's called something else. It's designed to literally microscopically examine slivers of sedimentary samples.
Sedimentary, metamorphic, and igneous. Any kind of
Yeah. And he just wants to say that using what little he's picking and choosing from, this is why we don't understand it. No, you're taking one piece of the information that we have and saying that that's all the information that we have. There are so many things that are involved with coming to a conclusion. It's whenever you talk about anything within earth sciences and the natural sciences, especially with simple arguments, a simple argument is never right because of the sheer magnitude of what is involved in the explanation of that simple conclusion. Let's take Ken Ham's billions of dead things buried by rock layers laid down by water all over the earth. That's partially correct. To understand that, you'd have to understand the deposition of sedimentation, and that not all rock layers are laid down by water. Then you would have to understand that not all dead things are buried in rock layers laid down by water, because you've got stuff in tuff and tuffite. Then you've also got things in desert sediments.
Yeah. Like, maybe just to put it simply, he's saying we have one line of evidence from which we're deriving this whole idea of a grand cycle. No, we have 250 different lines of evidence. You can just only show one to make it look ridiculous.
Unfortunately, when you come to complex systems, there is no such thing as a simple answer. There's a reason why it's complex, and it takes years to understand it properly.
I mean,
Would you trust someone who is fixing your car who's only had 3 weeks of experience?
well, depends on what they need to fix, but maybe not.
Yeah, if they're changing your oil or your tire, yeah, that's fine. But if they're overhauling your engine, I think I'm going to go somewhere else for that.
Yeah, that's fair. Actually, here as a demonstration. Here, look, I have this big old dinosaur here, and I think it ate meat. I think that because of the teeth, because it had strong jaws, because it had long legs, and because its feet made it really good for running or for getting its prey. His equivalent to that is saying, "Oh, it can walk good, so you think it eats meat? A lot of things walk good."
Well, you would actually take into account that where the eyes are, it's got binocular vision, so therefore it would be able to hunt and prey and ambush and grab. So with those aspects, you take into different accounts, plus the sharp talons, sharp teeth, as well as the way that its actually body is positioned. It looks more like something that would rip and tear rather than chew and bite.
But I'm just saying, like, what he's doing is basically saying, "Oh, you're saying it has 3 toes? Well, that doesn't mean it ate meat." He's ignoring all the other pieces of evidence.
Yeah, but that's why I said the sheer. You're a bastard, Hillhugger.
Okay, you are correct. You are correct. And before someone asks, it did not have wings either.
Well, it might have actually had.
Oh, wait, John got it. Yeah, a crystallographic microscope.
Yeah, thank you very much. But
Yes,
again,
thank you.
That's why it wasn't actually a microscope. It's got something else called. It's fascinating.
But it's a specialized microscope, but it is still a microscope. So we just called it a microscope for short.
It was a microscope with extra bits attached.
Yeah.
It can't fly because its flappy flappies weren't big enough.
Correct. But it also didn't have flappy flappies.
Oh, it might have had flappy flappies. We don't know if it had real flappy flappies. It could have been like
no. It did not have flappy flappies. I can say
floppy floppies.
I can say that with a pretty high degree of certainty that it did not have flappy flappies.
Well, emus have got flappy flappies, even though they're more floppy floppies.
Yes, but emus are descended from birds that could fly. That T-Rex, none of its ancestors left the ground.
Well, it might have left the ground when it falls off a cliff.
Okay, none of its ancestors flew more than falling with style.
Thank you.
It also just isn't in the right lineage for the right kind of feathers to produce wings. It's just like...
Oh, come on, don't ruin my delusion with your absolute facts. It's not fun.
Oh, don't worry, I'm about to do that a lot. Like, here is a actually very good reconstruction of T-Rex's closest relative that we know had feathers. It had one or two types of very simple feathers. It had no flight feathers whatsoever.
It looks like an Allosaurus derivative, that sort of thing.
It looks like it. It's a very... Okay, that's...
It looks like it's in
that's
that
the
family.
pterosaur... Ignore this. It's the pterosaur heresies. That dude is actually insane. Anyway, it is a very basal tyrannosaur. Tyrannosauroid, I believe.
So it would have been just after the divide between the Allosauri and the Tyrannosauri.
Not necessarily just after, but yeah, pretty basal.
Because it has,
in fact, it's still 3 fingers.
Yeah, that's why I said it's got some features that you'd assign to Allosaurus, but if you look at the skull, it's got things that are most definitely Tyrannosaurus.
The skull, the feet, there's actually a lot of things that go into identifying a Tyrannosauroid, but yeah. It looks like an Allosauroid because they likely lived very similarly, except that this guy actually liked pretty cold climates for the area.
In comparison to other areas, yeah.
Yeah, Allosaurus lived in a deserty savanna without grass. This thing lived basically in the mountain tops. Or at least a very high altitude forest with seasonal snowing.
I still want one.
Yeah, they're really cool. I like them a lot. Eutyrannus huali, who actually for once got a really good reconstruction in Jurassic World.
The sad part is I've got that game. I've never played it.
The sequel has a lot of good mods, but it for once got a beautiful reconstruction. Like, it actually looks like what it's supposed to be, and it behaves like it too.
Yeah, I've got all the DLC and everything, but I've never even loaded it up.
Do you have the first game or the second game?
Yes.
I got the second game too, and I have these guys, and I absolutely adore them. And okay, they are pointing out a few inconsistencies, but for the Jurassic series, this is insanely accurate. Like, I can recognize this as a Eutyrannus. That's more than you can say for a lot of their creatures.
Some of them are, what sort of drugs were you on when you were doing this?
Uh-huh. Yeah. But, yeah, very pretty. This is a mod, but also kind of pretty. And I was overjoyed. Like, that feathered species pack, just yes. So much yes. Like, for the first time, semi-accurate dinosaurs not from a mod. Lovely. Anyway, I guess we got to go back to Michael. So I think I will speed him up a little bit, just in interest of possibly getting this done.
Yeah, I'm trying to be nice and not interrupt as much and try and get this done within the hour.
A lot of his arguments, quote unquote, we've already covered.
This is an interpretation of data.
Well, let's just
do have wiggle. There's lots of other variables involved.
Egregious.
I don't believe they have anything to do with the Ice Age. How do we tell how many ice ages there were? Well, you go on land and you take a look. Usually in most areas, you see evidence of only one glaciation in areas glaciated. In fact...
God damn it, he said something egregious.
You were showing the bloody map, and like I said, I pointed out at least 5, and it was one glaciation effect. No! Look.
Yeah, at least we can say we already refuted it. But god damn it. You had 10 seconds. You didn't last 10 seconds. Like...
In fact, the secular scientists are starting to realize this. I just pulled up an article from the Technical Journal. It's called The Developments in Quaternary Science, volume 17, page 575 to 589. And this is talking about glaciation in Alberta. And this reinforces other papers in the past. This is by Lionel Jackson and 2 others. They conclude that in the Rocky Mountain foothills of Alberta, there was only one ice age. And also in other areas of Alberta, the evidence is that there was only one ice age. And in other areas where there's stacked till sheets, which...
Okay. So in specific areas of Alberta, there was only one glaciation, is what he's saying. If he's
No, that's not
representing
what
it
he's
correctly.
saying. But what those papers are saying is that.
Right. He's saying that's what the papers say, if he's
Yes.
representing them correctly.
That's the loaded question.
Yeah. Let's say Britain has a real drug problem. 50% of prisoners in Yorkshire have something to do with drugs. Okay, why did you choose Yorkshire? What about the rest of Britain? Oh, it's about 5%? I am pulling that right out of my ass, but a study says one thing does not necessarily mean what you're trying to say it means.
Yeah, it smells about as right as what he's saying.
Gee, if only there was a metaphor for picking specific examples like this. I don't know. I'm going to have some more of this cherry-flavored drink.
which separated by, we'll say, sand or other debris, they can be explained by one ice age. That's where they got the multiple ice ages at the boundary because of the complications of the ice lobes shifting and backing up, retreating and advancing, surging. So they're coming to the conclusion that there was only one ice age. But there is other evidence there was only one. South of the ice sheet, you had a lot of wind-blown silt called loess, especially in North America and Northwest Europe. This loess, when they analyze it, it comes from mainly, or almost totally, from what they believe was the last ice age. Where is all the wind-blown silt from all the previous ice ages?
It was blown away by the wind, and also you're wrong.
You also have to take into account some of it is washed away because some of it is wind-blown. And
it is dust. It is not hard to erode. But here in Iowa, once again, there is, I can't remember which it is, but there's a specific glacial silt loess deposit in eastern Iowa. It only exists basically in some very small isolated dunes scattered throughout the countryside, and then it was buried by subsequent deposition. That was not from the latest glaciation, and we can tell that because the deposits from the latest glaciation are on top of them, very well buried.
I haven't even opened it up, but would you like to know what the paper he drew from is about?
Oh, please do. What is it?
Sea level changes and neotectonics.
Are you sure you have the right paper?
Journal of Quaternary Sciences, Volume 17, Issues 5 to 6, Special Issues, Sea Level Changes and Quaternary Neotectonics. I now need to go to the pages, but let's see.
Do you want me to rewind so we can get the authors?
I've already got it up. I've got it on a separate screen, but here you go. It's a collection of papers, but that's what the journal is about. And I'll put it into there. Yeah, I haven't read through it yet because I haven't even started. But let's see, pages. It was page 575. So 445, 535, 540, 560. Revised chronology of the fjord states, Mosjøen in Greenland, predicting sea levels on the Australian coast. I can't find the right page. 575, so 589. Yeah, I can't find the paper. It's actually missing from the pages.
Was it possibly retracted?
Possibly, because it goes through all the pages correctly until you get to it goes to one by Anthony Long and David Roberts, which is 561 to 579, and then it goes all the way up to 580s with predicted and opposite. There's a chunk missing, but this is from his. It's from the claimed one. He says volume 17. Volume 17, yes. Journal of Quaternary Sciences, which is the developments in quaternary sciences. That might be where. It might just because that's a journal, and let's see.
Huh.
Well, I've got another one: developments in quaternary science. The Oscar Theta as proxies for quaternary climate change. Let's see. Pages 5, 300s. Volume 17 doesn't go up to 500 pages. This is what I do in the background. I'm always digging through it.
Yeah, no, you're totally fine, dude. Like, I honestly appreciate it.
Yeah, the volume 17 only goes up to 323 pages from developments in quaternary sciences for volume 17. And I will place the link in the chat so that way people can actually look at what I'm looking at. And I'll put it in the side chat too, so that way you can look at it if you want to as well. And that's a book series, and as you see, there's volume 17 pages, and it doesn't go to 500.
Oh, yeah, and for people who are curious, this is one major area where creationists and scientists differ. We make it easy as we can for you to find our sources, to show that we're not just making shit up. Wonder what that says about them.
Well, they don't know. They don't know where it went if it disappeared. So to me, this is pretty strong evidence there was only one ice age. But here's another piece of evidence. When you go beyond the edge of the ice sheet, maybe 100 miles north of the boundary, you find a few areas that were not glaciated. They were missed. They're called driftless areas. One famous area is in southwest Wisconsin. Another area is in northeast Montana and adjacent Saskatchewan.
Okay, the driftless area of southwest Wisconsin. Okay, I grew up in that area. Yeah, no. That area was glaciated. I know because I lived there. It was definitely glaciated. It just wasn't in the last major glaciation. He's just lying. Like, he's actually just lying. And I can say that firmly because I dug through meters of glacial till back home to search for fossils and rocks from Wisconsin and Minnesota. It is really funny when they try to cite like your hometown area to support their BS.
Found it.
Oh, you found the article?
Limits of successive middle and late Paleozoic continental ice sheets, interior plains of southern and central Alberta and adjacent areas.
Oh, if you want to share it, I can put it on screen.
Yeah, I'm just putting it in chat as well so people can actually have it. But this is the paper that he's referring to, and it doesn't support what he's actually saying.
Oh, well, go figure. I mean, we don't have to go through the whole thing on stream, but what does the abstract say?
There is no abstract because it's from a book. There's an introduction.
Ah, okay.
The abstract consists of less than a paragraph. It's not really an abstract. You've got the link there if you want to bring up and look at the abstract. I'm actually going through the body of the text just because I always skip the introduction and the bodies.
Yep. Yeah, okay, so this is just in Alberta and adjacent areas. Here, wait a second.
It makes it very, very sad when it starts saying other glaciation effects have also assisted with it.
Wait. Unless I'm misreading what it says in the introduction, because I am reading that, it's just disputing which glaciation contributed to the deposits. That's all it's doing. It's saying it was glaciated, just a different glaciation. Holy shit!
I went to the part he said no. So I went for the person that he was talking about. I found the closest article that has something to do with it, which fits the page numbers he gave. But it doesn't say anything on what he's saying.
Yeah. Sorry, Trojan, or sorry, Hill Hugger. This isn't a Trojan source. This is a Trojan horse with a kick me sign on its ass.
But
Like,
I went for
holy
his
crap.
I went exactly for where he said. It wasn't there because it doesn't go up to the numbers he said. I went for the author itself, and then I had to find where is this actually from. This is the quaternary glaciation, extended chronology, a closer look, which is not developments in quaternary sciences.
Well, really? It says developments in quaternary sciences at the top of the page.
No, that's the group it's actually doing. The actual...
Oh, it's a book series. Okay.
Yes. It's called Quarterly Glaciations, Extent and Chronology, a Closer Look.
So volume 15 of a book series.
Yes.
Yeah, okay. Bloody hell.
That took a bit of digging.
Oh, jeez. Okay, this is I'm actually gonna look through the authors it lists because one of my professors might be in here.
But I had to find the information that he was dumping, and it was just, no, it's not there. No, it can't be there. It's here, and it doesn't even say what he says it does.
Oh, hey, I think I spotted one of the grad students who went to my university. I think.
I thought you would enjoy it, but like I said, it's good to have that sort of information out there. But as soon as I find the real thing, it was just, that's not what it says.
Yeah. For the record, Neil, if you ever see this, I was not the best student in your class, but I absolutely loved it. Oh, boy.
At least now you've got the information out there to correct his addendum of where he said it was.
Yeah. I've already burned through my drink. I'm gonna go get another and let it play.
Yeah, just let it play because I have nothing else to add.
That were missed. Well, why would they be missed? They were not glaciated at all. If you had multiple glaciations, a couple glaciations, 4 like they used to believe, or 50 now that they believe, how could those places be missed all this time? But in one ice age, of which the ice sheet was a lot thinner than they believe, which there is evidence for that, you can miss a few areas by chance. So it can be accounted for by one ice age in which the ice sheet was fairly thin. One more piece of evidence that there's only one ice age, there's maybe a half dozen, is that a lot of animals lived during the ice age. Woolly mammoths, a lot of them are extinct now. At the end of their last ice age, in their scheme, we had huge extinction, a major mystery of science. We didn't have any extinctions after any of the other ice ages, or except maybe isolated 1 or 2. But we had huge, massive extinction of large animals at the end of their last one. Why not at the end of their 50 have all these extinctions? To me, it's because they never existed, but only one, and it was after the end of the post-flood ice age. Here we are at the northern end of Banks.
Okay, sorry, I had to run back and correct that. Animals were going extinct all throughout the last few million years. Like, a lot of them. It's just the last one happened to finish off a lot of them.
But also the fact is, we haven't found fossils of those particular animals. Most of them we find are in tar beds and bogs, as well as frozen in permafrost. Oh, but they're fossils. No, they have.
Yeah, and I mean, go figure. What are the chances that glaciers would grind up bones?
To make my bread.
Like, and I'm saying this as someone who has found tiny bone fragments of giant mammals in glacial till. Like a lot of it. They are there. They're just ground into bits because glaciers are unforgiving monsters.
This is why I had 2 liters of water ready for this. I'm still frustrated by it, though.
I am unfortunately seeing the bottom of my bottle of amaretto, and I am sad.
At least now you've
Thanks,
gotten
Lake.
more information.
Yeah, I've learned a bit this stream for sure. Thank you, dude.
It's all good. The whole point is actually sharing information.
True. Who knows? Maybe our next video could be more a paleontology subject, so I can teach you some stuff.
Yeah, I didn't really pay much in paleontology. I was more interested in seismology and the volcanology.
And I was the opposite, so hey, that works. See, here's a very important thing. If you don't know something, you find an expert in someone. You find an expert who does. Collaboration. I'm gonna need that root beer, hun.
Well, how about we call it quits here and go annoy Mark?
That could be fun.
Because that his little blast screen would be a good breakout part of it, because now it's already been going for quite a fair bit.
That is true. I guess we can call it quits. Do we want to watch any more of this, do you think, or do we want to go to a different video?
It might be good to go to a different video, but it seems that it looks like we've got 9 hours. We've got another 3 hours left about how much we've been going through and how much garbage is involved with it.
Yeah, and mostly, I feel like we've refuted just about everything in here. It's just that he keeps repeating himself.
We go on a lot of side tangents of things that are rather interesting when you come down to it.
Yeah. All right. Well, suppose we can call it then. You can have any streams on your Twitch channel or anything you want me to share for you?
That's so good. Like I said, I just prefer it to grow naturally rather than get assistance from other people.
Fair. In that case, let us end the broadcast. Have a good night, everybody. See y'all around.